represent students from K through 12, as well as the collegiate teams, which are under USC, UCLA, and CSU Long Beach. We do represent universities that are part of Vegas as well. Well, Nevada portion of it. So yeah, thank you so much for joining us. A quick background of myself. So I was an AIAA when I was in school at University of Texas in Austin. I graduated in 2016 and I moved out to California to start working at my first company, Virgin Orbit. I was there for 3 years and now I'm at another startup called Relativity Space. And I've been here for almost 2 years. During COVID, I realized that I just wanted to be a lot more active in just the realm of aerospace. I wanted to be able to give back to my community, be a leader, and help like be a mentor and educator to collegiate students as well as just students in elementary school, middle school, and high school. And I'm very humbled and proud that AIAA has given me a platform to be able to share my knowledge, my resources, my networking to all these students. So I unfortunately will not be able to stay for the whole time. I actually need to go to work. So I will turn this over to Ken, but if anyone has any questions, please reach out to me. I believe Ken will be sending out my contact information and it should already be on the flyer too. So thank you so much for joining us and I'm looking forward to hearing our students present. Thanks everyone.
Thank you so much, Coach Wu. Coach Wu is really passionate about what she's doing and really love to reach out to all of you and help all the students and educators. So please keep in touch with her. She's our representative liaison, a mentor for you all. So please, reach out to her. As I said, she said that her email is on the website, and I will post it as well, post it online as well. So, Coach, will you see that Diana? You said you were awesome. Yeah,
I did. Thanks,
yeah,
Diana. Yeah, I'm so proud of like our collegiate teams and like, the amount of events and stuff we have put together. And seriously, like if any of our attendees, if y'all have any questions, if y'all have any suggestions on type of events you want to see from AIAA, please do reach out and let us know. We're always looking to hear back from our team, just so we understand what kind of events we want and be able to resources and make it happen.
Yeah, you're right, Coach, and we are so lucky to have you, and really appreciate that. You see, this AIAA area is really, really fantastic. We have amazing, people today, as you see, and so also a lot of people in this area, waiting for you to reach out to them. It's a great potential and a wonderful people here. Really appreciate. We're so blessed to have you here with us.
Thank you for the kind words. Appreciate it. Thank you.
Thank you. All right. So yeah, as Coach, unfortunately, she has to work today, but she's always there for you. So don't worry about it. So she's always with you. So our first speaker today is very inspiring, and his talk is really fascinating. So really wish everybody here, who's every passionate about aviation, aerospace can benefit from it. So there's Mr. Phil Barnes. And let me make sure that he's spotlighted. Let's see. Looks like he's there. Okay, so yeah, Mr. Barnes is with MSAE from Cal Poly Pomona and the Bachelor of Science in Mechanical Engineering from the University of Arizona. He has authored AIAA, SAE, AAS, and ASME papers on diverse topics, including electric flight, aerodynamics, propellers, and mechanics of gears, Keplerian orbits, and dynamic soaring flight. Recently named Cal Poly Aero Engineering Alum of the Year, where he presented learning from the birds to graduates, families, and the faculty. Phil has given several invited travel paid lectures at universities, including USC, OSU, UIUC, and the University of Dayton. Phil frequently mentors engineer students with their capstone projects, and the fruits of such collaboration often appear in his technical papers and presentation. And just remind everyone, actually, this February, we post one of his great articles about wright flyers their analysis of aerodynamics. It's fascinating. Everybody loved that. You should look at it. It's on AIAA-LLV.org /download. I'll send you a link. Please read it. It's fascinating. So without further ado, let's welcome Phil. It's all yours.
Hey, thank you, Dr. Louis. Let me go to share the screen here and share and function F5. Let's see, slideshow. I always have a little bit of difficulty with Zoom. Let me try this. Okay, there we go. Do you see my title slide?
Yes.
Okay, the title slide is up. Okay, aircraft energy gained from an atmosphere in motion.
Excellent.
Okay, very good. Okay, thank you very much. It's a pleasure to address this interested and focused audience. Today's presentation is going to be a sort of an application of multidisciplinary engineering to study a phenomenon of the natural world and then try to apply that in the human world. Dynamic soaring and regenerative electric flight are topics of great interest for the coming age of green flight. For both types of flight, the aircraft operates and/or maneuvers intelligently to extract energy from an atmosphere which is itself in motion. Today's study, drawing from several disciplines, learns from the birds and human visionaries, first to understand how the wandering albatross uses dynamic soaring to remain aloft indefinitely on shoulder-locked wings, and second, how a regenerative electric aircraft, depending on geography and weather, might fly an entire mission powered solely by atmospheric motion. Before I go any further, Ken, when do I'm going to watch very carefully my time because we have following speakers, and I definitely will finish on time. When do I have to finish this up?
It's around 11. I'm sorry. Let me see. Right now it's 10. I think around. You have like 45 minutes.
Okay. Well, give me a warning. Give me a 1 minute warning when we get to that point. Okay.
Yeah, it's around 11. Sorry, 10.
Okay.
10:55.
Okay. All right. The presentation we'll visit not necessarily in this order. We'll visit with various visionaries of green flight. We'll show actual data for various types of atmospheric motion, updrafts, wind speeds, wind profiles, things of that nature. We'll do a little bit learning from the birds. We'll talk about the generalized performance in steady state climbing, sinking, or turning flight. Introduce the aerodynamics of a so-called dual roll propeller and airborne wind turbine, or wind prop. And then we will move into electrical engineering with the very basic principles of a permanent magnet brushless DC machine and its power conditioning, which is a very important topic.
Excuse me, Phil, your screen, your camera not showing up. You turn it off deliberately? Or...
I turned off my camera. Is that okay?
It's okay if you prefer, but the audience might want to see
Start video. There you go. I'm back on again. How's that?
Great, great. Excellent.
Okay. Then we'll move into regenerative electric flight simulation. I have two videos. If we have time, I'll be able to show both. One is a slow floater, and the other is a high-speed aircraft. And let's start off with a little bit of aerodynamics here. This is a formation of white pelicans, which I was a pleasure to encounter. And I'd like to ask as food for thought for the audience, does the lead pelican enjoy a benefit or a penalty of leading the formation relative to flying solo? And to answer that question, we will apply the classical aerodynamic tool of a horseshoe vortex to the wingman or wingwoman. So here's a horseshoe vortex applied to the following bird. And the vortex, the horseshoe vortex is like a tornado and is going to induce upwash upstream and is going to also induce upwash outboard of its wingtip. And so we discover that the lead bird will actually enjoy a slight benefit of flying in formation. And the benefits are much greater for all the followers. But this is an example of the birds generating their own atmospheric motion for their own benefit to increase the range for a given amount of energy expended. One of my friends, a retired Navy jet pilot, said that after my presentation, he came up to me and said, I could feel my wingman when I was flying in formation. I could feel my wingman coming up behind me. Okay, our next example from the natural world is the great frigate bird. We have at the lower right male, and up at the top we have female. And the frigate bird is nature's natural regen. It soars up and down day and night on thermals, up to around 3 kilometers. It has the lowest wing loading of any bird. You'll find these, for example, in Baja, California. They have some sort of an energy sensor, particularly at night, you would think. They're able to sense whether they're in sinking or climbing air. And of course, they're going to make sure that they get out of the sink and move into the updraft. They have some sort of a sensor like temperature or pressure that allows them to detect whether they're gaining or losing potential energy. A curious feature of this bird, it cannot ever touch the water, although it has to come down to the water to pluck food from the surface. It cannot get its wings wet because it has permeable plumage. If it gets its wings wet, it will never get back into the air. Sortie duration up to 4 days, distances up to 1,800 kilometers. Extraordinary bird. Okay, 150 million years ago, we had Archaeopteryx, the fossil which showed that the birds had evolved from dinosaurs. And one of the early flying creatures was neither dinosaur nor reptile. We don't know what kind of animal it really was, but it was certainly flying. And that's Pteranodon, huge bird, 9-meter wingspan, lived until 65 million years ago when we had the massive extinction. One of the interesting things about this bird was its little finger grew out with evolutionary time to become its main spar. The fossils of the Pteranodon have been found far out at sea, suggesting that it may have implemented also dynamic soaring to fly around. And it's also been speculated it doesn't have much chest muscle to do much in the way of flapping. Amazingly, just before Pteranodon went extinct, an early albatross was sharing the ocean skies. So imagine we have both types of creatures sharing the ocean skies. This happens to be Osteodontornis, also a huge bird, 6-meter wingspan, about 21 feet. Living fossils found 55 million years ago, and of course, an earlier version 65 million years ago. Today, we have the world's largest living bird is the wandering albatross with a 3.5-meter wingspan, 12.5 feet or so. The observations of well-known naturalists we have from Jacques Cousteau, the albatross can remain master of its course, going all the way around the globe and against the strong winds if necessary, all without a single beat of its wings. We have Sir David Attenborough, who said that the albatross can maintain swooping soaring flight for hours on end without a single wing beat. So it's going to appear to defy the laws of physics, but we're going to show in this presentation that indeed the bird does follow the laws of physics, as it must. Some of the features of the albatross are it's going to extract energy, as we will show, from the lower 10 meters of a 100-meter tall wind boundary layer. For those of you who are aerodynamicists, you know that the boundary layer thickness grows with the square root of x, and the square root of x can be quite large when you work your way out to the middle of the Southern Ocean. The bird we will show that for dynamic soaring, it will climb upwind and dive downwind, and is going to typically pull a 3G turn every 20 seconds. Many of you in the audience have been in a private airplane that perhaps pulled 1.5 Gs, and you know how uncomfortable that is. Albatross is doing 3 Gs every 20 seconds, and with no problem. It can travel in any net direction without flapping its wings, and we will show that with our simulation. And of course, it's able to follow the terrain, the heaving waves, often half asleep. It will navigate with pinpoint accuracy every 2 years to the location where it was hatched and meet up, hopefully with good fortune, with a lifelong mate. The young birds travel 6 times a year around Antarctica. And In some cases, witnesses have seen albatross on their fledglings, on their maiden flight, lift off and practice dynamic soaring right away, without any training whatsoever. The albatross, as I mentioned, has had 50 million years of evolutionary perfection, optimizing its wing shape and size for the boundary layer that serves as its home. Only within the last 0.001 million years, when the humans came along, the bird is now suddenly threatened with extinction. Some of the threats include the drowning with a long-line fishing fleet, human-introduced chick predators, their nests are right on the ground, and more recently, starving with the floating plastic at sea. Some scientists have projected that by the year 2050, the total weight of plastic at sea will exceed the weight of all marine organisms. So for that reason alone, I am hoping that we can all join a movement to stop wrapping electronic and other products in plastic. The Europeans have already begun the process of wrapping any product that's ordered or purchased in a box, wrapped it in paper instead of wrapping it in plastic. Okay, to understand the essence of dynamic soaring, let's do a simple two-step wind profile, and we'll imagine that we have a limousine traveling along the highway at 90 kilometers per hour, and we have two youngsters inside, and each youngster is holding a model aircraft or a model bird. And the first youngster tosses the model very gently, tosses it forward. Let's say it's a floater, tosses it forward, and even though it has 90 kilometers per hour of ground speed, it's unable to fly, and so it will fall to the floor of the car. The second youngster says, hey, let's open the moonroof, and the moonroof is open, and then toss the same model at a slight angle so that it goes up through the moonroof and encounters a blast of air at the top of the car, and suddenly it has 90 kilometers per hour of airspeed. And the model will be torn from the hand and will fly way up into the sky to convert kinetic to potential energy. This is really the essence of dynamic soaring, is to pull up to an increasing headwind. More difficult for people to understand is that an equivalent amount of energy is also gained descending downwind in a two-step profile. So another very, very important aspect of this chart is to show that flight kinetic energy is based on airspeed and not ground speed. And unfortunately, a European group had strapped a transmitter to the back of a poor bird and recorded its flight. And that inertial measurement unit was basically recording, in effect, was recording ground speed because of the shallow flight path angles of the bird. And they wrote a paper and claimed that they had discovered the secret of the flight of the albatross, and their conclusions were entirely erroneous because they had based their kinetic energy on ground speed instead of airspeed. Totally different results. Okay, here's an example of some actual data. This is a real snapshot of real-time activity with scientists had placed floating measuring units all around the Southern Ocean. We're looking up here at Antarctica, and the contours are representing a wind speed, horizontal wind speed at an elevation of 10 meters above sea level. And if you look at the scale, we can say that on the, roughly speaking, the albatross is able to fly around with 13 meters per second of wind speed at an elevation of 10 meters. And this is a wind profile, a typical wind profile. On the x-axis at the left here is a wind speed in meters per second, and the vertical will be the elevation. So you can see that the boundary layer of wind is very, very high, 1/10 of a kilometer high. And the albatross is plying the lower 10 meters or so of that to take advantage of a gradient. The gradient is over here on the right, showing that the most extreme gradient is down to like 1 meter above the water. Okay, so here's a force diagram on the bird, and we have the lift, drag, weight, mg, and we have a wind profile using W to represent the wind speed. And we have the red arrow in the center is a postulated dynamic soaring force. And you'll notice a similarity to Newton's law, except here the force is the product of mass times the rate of change of wind speed. So there's a mass times, it's not really an acceleration, but it's a rate of change of wind speed. Now, since the wind profile is fixed, the only way to have a W dot, the only way to have a rate of change of wind speed is to move vertically within the wind profile, as we showed in our example with the limousine. So the bird pulls up into the wind and gains kinetic energy when it does that. And then when it actually goes downwind, it actually gains kinetic energy again. So the component of this force that is aligned with the velocity, the airspeed vector V, becomes a dynamic soaring thrust. So let's take a look at the arithmetic here. Here's our thrust, there's our airspeed, and by applying a series of sort of chain rules here, we can synthesize the actual dynamic soaring thrust is proportional to the mass of the bird. The wind gradient W prime would be the vertical gradient dW to Z, and then some other angles and the airspeed. So, and the airspeed here, V. So the albatross is fairly heavy wing loading. And so, and that gives it a higher velocity. So it has a high velocity and it punches into the wind where the gradient is high, and the force is proportional to the mass of the bird. Flying in a gradient, remember that the gravity is a gradient of potential energy, and the force of gravity is proportional to the mass. So what we've done here is we have quantified, we've provided hard numbers to Lord Rayleigh's observation of qualitative description of dynamic soaring. Rayleigh around 1902, 1903 took a trip to the Southern Ocean and witnessed the albatross dynamic soaring, and concluded at that time that pulling up into the wind and diving downwind was gaining the bird energy. And he used a two-step wind profile in his classic article. I found his paper after I had written my own, so it was very gratifying to learn that he and I were in total agreement. Okay, a complex three-dimensional trajectory can be modeled and understood by breaking it into three pieces. We can look down on the trajectory and fit a turn radius. And we can look sideways at the trajectory and get a roller coaster loop radius. And each of those radii, each of those circles has according to Newton's law of acceleration and circular motion, we have a vector or an acceleration pointed toward the center of the circle. And then we also have along the flight path v dot. And so these three orthogonal accelerations can be broken up and modeled to model the trajectory and understand 3D trajectory. So we're taking advantage of the work of Isaac Newton, strong advantage of that. What we're going to do with our maneuvering simulations is we will schedule two angles, and then we'll let the equations of motion determine all the rest. So what better way to model the graceful flight of the albatross by using trigonometric functions to model its up and down motion and banking motion. And we can start with a simple sine wave for climbing and diving, and we'll need to modify one in relation to the other so that the bird doesn't crash into the water. And so we can apply a sine squared term. And when you do that, you get something like this. And so this allows us with a very compact equation and only one or two parameters, adjust those parameters until, and we let the bird go through one cycle of climbing and diving. And we adjust the couple of amplitudes until we get the result that we're looking for. We can also do some modifications of time, an auxiliary time for each cycle, so that the bird skims the water as it has been observed in nature, banking left and banking right. So we're going, as I said earlier, we'll do two schedules of some sort of these angles, and then let the equations of motion from Newton's law to determine everything else. Not to spend too much time on this slide, but I want to show that all of these equations are being used 10 times per second in our simulation to model the normal load factor, drag to lift ratio, tangential load factor, heading change, heading rate of change, lift coefficient, drag to lift ratio, and actual trajectory. So what we're doing is that we're picking a layer of air in the wind profile, and we're applying all these equations for the motion within that particular layer. And then then we apply these results down here. So a bird that might be flying in a circular pancake circle, when you apply the wind to that, you'll end up generating a spiraling motion where the bird spirals downwind or upwind, whichever way it's headed. And everything has been non-dimensionalized. This is a thrust group and a drag group. And you'll notice that the drag group is proportional to the normal load factor. And we talked about how the albatross is pulling 3 Gs every so many 20 seconds. And so it's very important that when you pull high Gs like that, we have a high aspect ratio to mitigate the induced drag. And that's why nature has endowed the albatross with an aspect ratio of something like 16. Okay, so here's algebatross. Algebatross is a mathematically modeled with equations from tip to tail and wingtip to wingtip, weighing 11 kilograms, aspect ratio 16, wingspan 3.5 meters. And we will basically analyze the trajectory and draw the bird every 10 times per second with our simulation. So let's cross our fingers and hope that I can pull this up. And this is available on my website. Of course, your computer, it's a .exe, it's an executable, so your computer will try to protect you and prevent you from using it, but it's entirely safe. It was written with Visual Basic 10 years ago. Let's see if it comes up. Here we go. Ken, do you see this big blue square?
Yes, I saw the square said real-time simulation of dynamic soaring.
Yeah, okay, so you should see right now 2 blue squares on the screen for the simulation.
2?
Okay.
No, I only see 1.
Okay.
I think people also see only 1 on your PowerPoint.
Do you see the bird in the middle of the screen?
Yes, with the white lines and the yellow.
Yeah.
Yes.
Okay. So there's the bird, there's the algebatross, and I'm blowing it up here. You see that? Okay.
No, I only see the one with white lines.
Right. So what you should be seeing is a side view of the bird with a white line, a line drawing, a wireframe model of the bird with a blue square background representing the ocean and the air. All right. I'm going to gamble that everybody can see this okay, and I'm going to hit the okay. Let's do the downwind. Okay, fly. Do you see the bird flying?
No.
We do not.
We can see only, this is the PowerPoint. Not the animation.
You're only in the PowerPoint. Okay, so let me stop here. So basically, okay. I need to do a new share.
Yeah, Diana and Alex also said they could not see.
Share.
No. Now it's good.
Okay, now, okay.
Yeah, Diana say she can see it now too. Oh, now you turned it off.
I turned it off. Okay. If I maximize the screen here, okay, so let me see here. I'm going to share the screen again. Click the simulation. Well, that's PowerPoint. I want to go. I think I have to have. Oh, I think I have to have the simulation open before I begin sharing. Let me do that. So there's a simulation. So now, minimize. Share the screen. Screen share. Okay, do you see the simulation? Do you see the, okay, full screen?
Now it's full screen, perfect.
And now say, okay, do you see the wireframe of the bird?
Yes.
Okay, all right, so let's do the downwind. Okay, the wind is blowing out of the screen and the albatross is doing what we can call a circumpolar circumnavigation maneuver where it is traveling around Antarctica 6 times per year. Notice it is not flapping its wings. It's losing energy going across the wind. Now it's gaining energy going downwind. Now it loses energy going across the wind. And now it gains energy upwind. And it continues this cycle, which includes a 3G pull-up every 20 seconds. And it can do this for hours on end. All right, let's hit the stop here. And this is traveling directly downwind. Let's take a look at the crosswind. Okay, so now the wind is blowing from left to right. Once again, the albatross is able to travel any direction that it wants to go without flapping its wings. Here we are, we're gaining energy, losing energy, gaining energy, pulling up. And I'll show a small trick here. One of the interesting things about the birds, soaring birds, is that they keep their sensor platform level no matter what the bank angle is. And so you'll notice that the head, and that's been preserved in this simulation, the head remains level regardless of the bank angle of the wings. All right, let's hit the stop button here and do the last one, which is actually upwind. This was a very difficult one to simulate until I discovered that we needed to keep low. So instead of pulling way up high, the bird stays very down low to avoid being blown downwind. And now it's actually flying, progressing upwind, directly upwind overall, with a sort of an S-shaped trajectory. So it's able to travel pretty much in a direction that it wants to go. And this is consistent with observation by Jacques Cousteau and many others. Let me see if I can return to PowerPoint. Okay, do you see a picture of Hermann Glauert now?
Yeah.
Okay.
Hermann.
All right. Okay, so we're now into the world of humans now, and we're going to be doing some electric flight here. And Hermann Glauert, the brilliant British aerodynamicist, was the world's top expert in propellers in the 1930s, and also an expert aerodynamicist. He was first to compute the distribution of lift on an unswept wing with any chord distribution and twist. He introduced the well-used propeller blade element method. He's half of the Prandtl-Glauert transformation, transonic flight, and with many other major contributors. And he said in his classic book, consider the case of a windmill on an airplane. He did not offer a specific application, but he knew that one day there would be an application of an airborne windmill, and we will be doing that in the remainder of the presentation. Here we have another visionary. We have Paul MacCready, and with his model dinosaur. Of course, Paul MacCready brought us the first human-powered flight. He then followed that up with an aircraft that powered solely by solar power, and then he went from there to participate in the development of ground electric vehicles. He wrote a classic paper in 1999 and introduced the regenerative electric flight concept. He introduced that with caution. Those are his words. He wasn't sure it could be made to work, but he introduced the concept of using the propeller to take off and then using the propeller as a turbine to regenerate the energy in the battery when the airplane encounters updrafts or ridge lift or final descent. Okay, so let's take a look at the cross-section of a rotor. We're going to actually, this would be a wind prop, and so being a wind prop, we're going to give it symmetric sections because we want it to be able to operate essentially the same efficiency, whether it's propeller or whether it's a turbine. And we've introduced here what's called a pinwheeling condition. If we have a very specific distribution of twist, R tan beta equals constant. Beta is the blade angle, and omega is the rotational speed, R the local radius, W the wind speed. The airspeed, of course, is constant for all the sections of the blade, and the rotational speed is, of course, also constant. And so it doesn't matter what the airspeed is. In the pinwheeling condition, the blade will have zero angle of attack all the way from hub to tip. And if you fly faster, it'll spin faster. If you fly slower, it will spin slower. But it will have uniformly will have zero angle of attack from hub to tip in this sort of a pinwheeling condition, provided it has been given a twist distribution of R tan beta equals a constant, and that can be a wide range constant. Okay, now if we increase the omega is the rotational speed. If we increase that by about 15%, all of a sudden we have an angle of attack on the section, and we have lift and thrust and propeller operation. Conversely, if we reduce the rotational speed 15%, so the omega vector is getting shorter now, the rotational speed has been slowed down, we'll get lift in the other direction, and we'll get drag and we'll get turbine operation and regeneration if we're hooked up to a motor or generator and battery. So we can define a speed ratio, which is very similar to propeller's advance ratio, but it's not the same. This speed ratio will be unity when we have a pinwheel operation, and the speed ratio will be less than unity for propeller operation or greater than unity for turbine operation. Now let's take a look. This study right here applies my propeller analysis model, which numerically integrates the induced velocities of all the wakes of all the blades, sort of a horseshoe vortex lifting line analysis, but it includes all the wakes, all the helical wakes. And we've got here an 8-bladed propeller, and then we have here a 2-bladed propeller. Both of these guys are the same diameter, and they both develop the same thrust. The difference between them is that the 8-blade propeller has a very high pitch angle, 30 degree at the tip, and is spinning very, very slowly compared to this guy. The 2-blade propeller has a more shallower angle, 14 degrees at the tip, and it is literally screaming. And many of you are aware of how uncomfortable it can be with a two-bladed prop. Can be extremely noisy. Tip Mach number effects are also going to come into play with the high speeds like that. But these guys are going to be shown by the analysis, fairly detailed analysis of both, finds out that the 8-blade has a very slight advantage, believe it or not, over the 2-blade propeller. Anyway, this is a plot versus speed ratio on the x-axis, and the speed ratio of 1, of course, is pinwheeling. And so when there's pinwheeling, there's no efficiency. It's efficiency 0. To the left of that, we have the efficiency of about 84% for the propeller operation. And to the right of unity, we have turbine operation, and we have about the similar 84%. Now, it's very, very important to notice that this definition of airborne turbine efficiency is totally different from the definition of a ground wind turbine. The ground wind turbine is limited to 69% based on the way the efficiency was defined by the famous German aerodynamicist Albert Betz. And here we have a airborne wind turbine. The efficiency is totally different. It's short shaft power times the rotational speed divided by force and velocity, the inverse of propeller. And that efficiency is about, as you might expect, as a peaking at about 85%. For regeneration. So keep in mind the shape of these two curves of efficiency versus speed ratio as we proceed into electrical engineering, because there will be an extraordinary synergy there. This is the corresponding force that we see versus the speed ratio. And so when we have propeller operation, we're way over here and we're climbing. We have the propeller blades are fairly highly loaded, fairly high force. Down here at cruising, notice that when you were cruising, only about 1/5 of the force required for climbing. Same thing that happens with your car. Your car might be a 200 kilowatt engine, but it only consumes 20 kilowatts or so traveling level on the highway. If you encounter a steep slope, then that's when the 200 kilowatt becomes necessary. Pinwheeling down here with a very, very tiny negative number. It's not drag free, but it is a very, very small penalty. And so there are some concepts of airplane where, particularly for urban air transport, you could have multiple propellers, and you'll need much more lift to develop vertical lift. But then when you start flying horizontally, you only need a very small number. If the LRD of the aircraft is 10, you only need 1/10 of the thrust. So you either throttle back an engine or whatever you're using way back down to 1/10 of its capacity, or you let the propeller, or you only use some propellers for cruising and turn others off or let them pinwheel. And the penalty for pinwheeling is actually very small. Over here we have regeneration at maximum efficiency, and then over here regeneration at max capacity. So the forces are much smaller in regeneration, but the efficiency is still about 84%. Okay. This is Michael Faraday. With little formal training, he was one of the greatest scientific experts of all time, according to Ernest Rutherford. Einstein had 3 portraits. Yes.
9 minutes.
9 minutes. Okay, thank you. Okay. Einstein had 3 portraits in his office, and Newton, Maxwell, and Faraday. Okay, now remember the shape that we saw earlier for the wind prop. This is the efficiency characteristics for a motor generator, permanent magnet motor generator. And the red curves are the efficiency curves. And you'll see that versus the speed ratio of unity, you'll see that we have the same behavior that we saw before for the wind prop. Here we have for motor operation and generator operation. As an aside, everything here has been non-dimensionalized, non-dimensional current, non-dimensional torque. As we all know, that at 0 RPM, the motor develops the highest torque, and that torque falls off as we head toward unity speed ratio, where the EMF developed by the motor has built up to the point where it equals the battery, and so there's no current in the system. For the red curves, as the efficiency of the motor generator improves, we'll move those red curves, will penetrate deeper into the corner of the theoretical curve, which is a dashed blue line, which is sort of a triangle. You climb up the dashed line and then instantly drop to 0, if you will, theoretically, at a speed ratio of 1. In practice, we get those smooth curves. So with things like superconducting and other improvements, the red curves will penetrate deeper into the corners heading toward higher efficiencies in the 90s. Okay, so now we have a permanent magnet motor generator together with its inverter rectifier and the power conditioning DC-DC converter. The DC-to-DC converter is absolutely essential for efficient operation. Absolutely do not want to apply pulse width modulation to the main current, something that's done with a model aircraft speed control. Because when you apply pulse width modulation to the main current, the system will be highly efficient when we have the on cycle, but then when the pulse is turned off, we have the parasitic losses of the motor persist without doing any useful work. So efficiencies of the system drops to about 40% if you use a typical chopping speed control for like a model airplane. So that's why today's electric vehicles, ground electric vehicles like the Toyota Prius, etc., they use a DC to DC converter. And what that does is that when you're cruising, it steps down the voltage applied to the motor. And when we're regenerating, it actually steps up the voltage generated by the motor so that it can pump energy back into the battery. Okay, given my 9 minutes, this is a typical inverter rectifier, which is basically 6 transistors. Each of the transistors has a flyback diode, so you can't just chop current to 0 without dissipating the energy. And turns out that the inverter does not really invert voltage. An inverter toggles the battery voltage on and off for each of the 3 phases, with one of the phases being floating at any given time. These transistors are nothing more than high-powered light switches, and we have a diagonal pair are used sequentially to energize the 3 phases. Now, for regeneration, the flyback diodes become critically important, and so they are left in the diagram here. And when we spin the rotor, it turns out that we get a free regeneration for free as a result of the flyback diodes, which have about a 0.7 volt loss, but that's pretty small as we talk about 500 volts for a Toyota Prius electric car or a comparable sized electric aircraft. 500 volts is very typical, and some of the high technology hybrid electric aircraft are looking at 1,000 volts and even much more than that. So the diodes, flyback diodes, are giving us free regeneration, and that the regeneration looks like the signal at the lower right-hand corner. A little bit of ripple, that's actually a minor amount of ripple, current right back into the battery. So we're going to apply these with, this happens to be a shot of what I've called Coulomb Keeper, a silly name for an airplane which is very frugal with the storage and expenditure of electrical charge. And its high-speed partner, Faraday First, in the background. Both aircraft, whether they're slow or fast, are using 10 blades, very low, slow spinning 10 blade rotors for high efficiency, and to allow for the high speed aircraft to allow the highest Mach number that you could get. Today's Airbus A400M transport flies at Mach 0.7 on propeller power. Both of these aircraft, by the way, have been modeled with equations, Python equations in Blender. Blender is a free computer graphics package, extremely powerful, and it has a Python programming window where you can mathematically describe the shape of the fuselage and the wing and a blade, a propeller blade. You can bring in a light, you can apply surface texture to the surfaces and then render it. And so it's a very, very capable package, and available for free, blender.org. Okay, so how much time have I left, Ken?
You have 4 minutes.
Okay, very good. I think we're on schedule. Okay, this is a generic aircraft in steady state conditions, and it can be either gliding, it can be climbing, it can be banking, it can be banking and climbing, it can be banking and descending. As long as it's steady state, we have this equation, we get this equation for the rate of change of elevation, dz/dt. It has a drag to lift ratio, it has a airspeed, and it has a thrust to drag propulsion group, thrust to drag -1. Keep in mind the thrust will be negative when we're regenerating. Okay, so here we have our clean airplane. Look, we're going to take Coulomb Keeper, take all of the propulsion package off and start with a clean airplane. And the aerodynamics of that give us something like a 1 meter per second sink rate where the airplane is clean. But when it is regenerating, of course, we talked about how you get negative thrust. And of course, we're going to have a penalty there. So we, in very round numbers, the airplane sinks at 2 meters per second when it has when it's regenerating. That's modified somewhat by whether we are doing maximum efficiency or maximum capacity regeneration. Okay, and now we have Herman Glauer did an analysis of updraft stream function study. And he showed that if we fly with these various circles, we get so much of the horizontal wind speed as available as an updraft. And here's some typical terrestrial wind data, probability distribution. By the way, anytime you do a probability distribution, whatever the units are on the x-axis will be the inverse of that on the y-axis. And the total area under the curve will be unity. Anyway, from this composite data, it looks like 6 meters per second of wind speed is a reasonable number for modeling ridge lift analysis. Okay, and here we have one of the Wright brothers soaring over the dunes of Kitty Hawk, North Carolina. Must have been an incredible experience for them. Airplane happened to be slightly unstable, but they were able to manage that. This is a vector diagram at the right of equilibrium of the lift, drag, weight. And it turns out that the amount of power provided by the ridge lift is given by the product of drag and velocity, and that turns out to be equivalent to the weight of the aircraft, the product of the weight of the aircraft and the updraft of the same. So here we are, we're flying in ridge lift, but let's take a look at some of the numbers for various modes. Thrust to drag ratio. Let's come over here real quick and look at what's happening with the energy power. Climbing, we're consuming 26 kilowatts. So I have a negative number there. We're losing 26 kilowatts to climb. Cruising, 8.8 kilowatts. Ridge lift, we are regenerating, so we're earning 3 kilowatts. If we go into a thermal, we'll show that very shortly here, we earn 1.4 kilowatts. and this descending steep descent, we can actually pump 5 kilowatts back into the battery. So the price that we're paying here is we have like 2.5 minutes of regeneration are necessary to just pay for each minute of cruise. And we have to regenerate for 9 minutes to pay for every minute of climb. So depending on geography, if your airport is close to a cliff or close to a ready source of thermals, you could conceivably take off, climb, and regenerate for a while and come back and land on a full charge, the holy grail of a complete flight powered solely by atmospheric motion. Here's a typical profiles of a updraft of a thermal, and the airplane is sinking, and because the updraft is higher than the sink rate, it carries the airplane up into the sky. So let's take a look. Do I have 1 minute left, Ken, for a video?
Yeah, of course, go ahead.
Okay, so let me do a new share. And screen. Do you see Coolant Keeper on the screen there?
Yes, now, yes.
Do you see the airplane spinning around?
Yes.
Okay. Okay, the mathematical model I provided to my friend Mario Marino, and he's an expert, and he actually animated the aircraft according to my instructions. Here we are, we're taking off. We're using differential thrust to, we have one person can operate the whole plane. That's why we have the winglets pointing down, so one person can operate this airplane by him or herself. Dual counter-rotating propellers, we're taking off. We have a full charge there, and we may have, this full charge may have been the benefit of a windy day, putting a safety perimeter around the airplane and recharging the battery. So we're taking off with a full charge, climbing at full power in accordance with the numbers that we showed earlier. And now we're entering to a ridge lift. We're going to fly along the ridge. We're earning 3 kilowatts pumped back into the battery. Now we're going to encounter a thermal, and as you can see, the aircraft is actually climbing because it is, even though it sinks at 2 meters per second, it's in a thermal which is rising at 3 meters per second. So the aircraft is actually gaining internal energy as well as potential energy as it climbs in the thermal, provided the airplane is very efficient. And finally, we're touching down with regeneration in descent. And let's hit the escape button here. There we go. And I think we're ready to go to, do I have 30 seconds left?
Yes, yes.
I'm out of time. Okay. So conclusions. Regenerative electric aircraft is getting an internal energy gain from atmospheric motion, updrafts or thermals, exploding ridge lift, thermals, and descent. It requires a high LRD and a low wing loading, so it's basically a sailplane equipped with a regen package. We can steepen the descent, we get landing thrust reversal, recharge parked in the wind and the field. A regen is coming soon to an airport near you. Okay, for the Albatross, we're gaining kinetic energy from the atmospheric motion, and we're flying in up and down in the wind profile, exploring the vertical gradient of horizontal wind. This requires a high LRD, as we had before, but it requires a high wing loading. So whereas the Regen Electric was a floater, the Albatross is a high-speed, high wing loading, punching into now to get energy. It's making net progress in any overall direction. It's nearing sudden extinction after 550 million years of evolution. We're suffering incredible pollution with plastic at sea, et cetera, et cetera. So anyway, let not the Albatross vanish from the earth on our short watch. Okay, you can visit my website, howfliesthealbatross.com, for further details. Thank you very much, everyone, for listening, and thank you, Dr. Louie, for the opportunity to present.
Thank you, Phil. This is fantastic, very inspiring. We already got very positive feedback. Everybody's so happy. Unfortunately, we are running out of time. So, but Phil will be back in the career panel. If you have further questions, you can ask him. And he will also be there in the breakout sessions. Not only he care about you, he will give you some share his career experience, and he will be also happy to answer questions. Thank you, Phil. Thanks a lot again. Okay, so our next session will be the student branch presentation. So the first one will be UCLA student branch. The branch chair is Oliver, Mr. Lam. He said he will have, yes, go ahead.
Hi, good morning, everyone. Let me just pull up my slides.
Yeah, don't worry about the time because 5 minutes late, we'll just push off a little 5 minutes. So go ahead.
Okay. Everyone can see the slides well?
Yeah, I can see it. I can see it.
Okay. So good morning. We're AIAA at UCLA. We are the student, AIAA student branch at UCLA. So just here are some photos of us. Okay, so who we are. So at UCLA, we're a professional aerospace society, and we have 3 main objectives. We focus on professional development, academic support, and our main focus is our technical projects. So just to go over our events real quick, we've been doing virtual events this year, of course, due to the pandemic. We've hosted career fairs, info sessions. We started a mentorship program, so underclassmen can connect with upperclassmen, form a relationship to help them through, especially during this time. It's so difficult to navigate through school when you're not actually on campus. So with the mentorship program, members can reach out to older members for help. We do professional development series, so we do resume workshops, mock interviews, basically anything that helps people with their careers future. We also do class planning and help, and we also help do K through 12 outreach. But of course, this year it's been very difficult to plan anything, but we have participated in some virtual events. And then I'm just gonna go right into our technical projects because they have a lot to say. So we are the umbrella organization for Design, Build, Fly at UCLA. So that's on the left. We have our rocket project, and we have our unmanned aerial systems. So I think, yeah, I'm gonna introduce Paul Hawkins. He's going to talk about Design, Build, Fly.
Yeah, so Design, Build, Fly at UCLA is one of the AIAA technical projects. You can see some of the pictures from our planes the past couple of years on the slide here. So moving on to the next slide. So DBF takes an RC aircraft throughout the design process to build planes for competition each year. So each year the parameters change. You can see we have a foldable wing in one of the pictures. We have a plane with a radome that can drop projectiles. We have a plane that can take off from a short ramp. So every year these change. So the next slide, you can see that our group is split into 5 main sub-teams. They're most active during different times of year. So right now we're kind of the manufacturing phase and kind of done with the design portion. Typically members are most heavily in 1 or 2 of these sub-teams. We'll have a virtual competition in 2021. So the main challenge is to hold a sensor and containers as payload, and similar to last year, deploy, stow, and recover a sensor. So a couple of weeks ago, we finished the 60-page design report. Now we're starting to build components at individual households and bring them together to Westwood for final assembly. And competition will be virtual this year, so we won't be driving to competition in Arizona. So we'll have a pilot and a member filming a video at a nearby airfield to submit for competition. So you can see our manufacturing plan on the next slide. It's pretty heavily backloaded since we're only building 1 plane this year. So just a quick look at our plane on the next slide. So we have the wing, NACA 2410 airfoil, close to the maximum wingspan allowed. We have a sensor shaped like a rocket for efficiency. We have a winch that we mostly printed out of 3D parts we can unspool to release the sensor through bay doors and recover it. So this year we expanded our general new member training and we found that it's been pretty successful. So we'll kind of expand it for future years, even when we're back in person. We'll also run through more kind of advanced concepts after we have competition next month. And then you can see our social media page on the next slide.
Yeah, thanks, Paul. And I guess I just wanted to say, like, with everything being virtual, we found like some aspects of being virtual is actually beneficial, and we're planning to, of course, keep some of those aspects next year, including like recording our meetings, so that if members can't make it to certain meetings, they could always rewatch lecture or meetings and stuff. So we're very looking forward to incorporate everything next year when hopefully we go back into person. Now I believe Lindsay will talk about Rocket Project.
Hi everyone, I'm Lindsay. I'm Director of Outreach at Rocket Project, and we can get right into it if you go to the next slide. So the goals of Rocket Project at UCLA are to cultivate the next generation of rocket engineers and industry leaders through a structured educational pathway, increasing project complexity, and of course, with required safety training. Also, my favorite part is giving back to the local community through K-12 outreach. We have a little bit more than 150 active members right now, especially because we do have so many opportunities virtually. It's really easy for people to get involved. We can go to the next slide. So just a little bit about our project growth over the years. It started in 2013, and until about 2016, there were 30 active members who worked on a commercial hybrid motor. They would do about 1 launch per year and have 2 hot fires per year. Starting in 2017, we partnered with the Mechanical and Aerospace Engineering Department here at UCLA. And now we have about 150 active members, and we work on both a student-built liquid and hybrid propulsion system. And so each year we can get about 15 hot fires in and 3 launches. We can go to the next slide. Here's a little bit about our project pathways. Usually your first year, you'll start in RISE, Rocket Introduction for Student Education. You work on a small solid. You'll move into our Prometheus team after fall quarter of your first year. And so you'll have both winter and spring quarter to work on your hybrid rocket. And then after that, you move on to Aries, which is a little bit more complicated of a system. And we'll get into a little bit more detail on that in the next slides. So RISE is the new member education program. It basically just teaches what is rocket engineering, and you're able to design a couple projects. It's usually a 2-unit course at UCLA, but we were able to do a virtual version for fall of 2020, where we had 5 sections of about 25 students enrolled in each. And we've had excellent member retention since then. They were able to design a couple rockets, just simulations and everything like that. And in the next slide. After that, they move on to Prometheus, which is our hybrid team. Usually the goal of that is to design and build hybrid powered rocket for launch at Spaceport America. And this year, unfortunately, that was canceled. So we hope to be able to launch in a local competition, given that the school will approve of that. We also, something that's really cool about having this hybrid team is that people with not much experience are able to get leadership positions and learn from mentors that are more experienced in Rocket Project at UCLA. Usually we can get about 12 static fires in. Over the past 3 years, we've been able to get 12 static fires in. And we also, in 2018, finished 2nd place at Spaceport America. And there's about 80 members now. We can go to the next slide. Aries is our liquid bipropellant team, and we are one of 7 universities to build this type of rocket. Of course, the goal of Aries is to cultivate experienced rocket engineers and safe ones through the design, build, and test of a liquid bipropellant rocket up to 45,000 feet. And since this is what is seen in industry a lot, it prepares members for their career. We have a 1-year timeline for that, and we are able to maximize educational value since we build our own engines. There are about 60 active members on this project. And lastly, the next slide. There's STEM outreach, where we are dedicated to inspiring youth and promoting the STEM field. We usually organize trips to low-income schools in the Los Angeles area, talk about UCLA, Rocket Project, STEM, engineering, and they're able to usually build and launch small 3D printed A-motor rockets. And last year we had about 3 school visits per quarter. We were able to visit the Children's Hospital and host 60 Girl Scouts to earn their rocket patch. This year, we've had virtual outreach opportunities, even reaching as far as classes in Las Vegas and various Boy Scout troops. It's been really awesome. And we have also started a video series where we finished our introduction to engineering for kids, focused about 4th through 8th grade. And we can move on. Here are just some pictures, because when it comes down to it, we all learn so much through Rocket Project at UCLA, and we want to be able to engineer change in our community. So thank you guys.
Now David with UAS.
Hi, so my name is David Thorne. I'm the president of Unmanned Aerial Systems at UCLA. We're the third and final technical project under AIAA at UCLA. So if you go to the next slide, you'll see just a description. We're primarily a project-based club with about 30 members. We design, manufacture, and test autonomous drones. We do both fixed wing and multi-rotor, but we pretty much focus on multi-rotor. And our favorite aspect is that we allow our members to do a highly interdisciplinary project that includes mechanical, electrical, aerospace, computer science majors, and plenty others, all working on the same system. So if you go to the next slide, you'll see we previously focused on AUVSI, which is a mock search and rescue competition held in Baltimore, or Maryland, near Baltimore every year. But we have after it got canceled last year, we focused our attention on 2 new projects. The first of which is a NASA-sponsored research project, and the second one is a competition sponsored by NIST. And I'll go into more detail of what each of those are in the following slides. So the first one is this NASA Undergraduate Student Research Challenge. It's a grant focused around allowing undergraduates to decide on a research project and see it through. So we got about $12,000 to build a system which would have multiple drones docked together, be fixed together, and then fly to try and maintain either payload or extend the range of each of the individual drones. And we're currently in the testing side of this. We've gone through a preliminary and critical design review, and we're about to make our first full system, physical system, right? And then the other project that we're working on, which is on the next slide, is the First Responders Challenge. So our drone for this is the Bioenergy Robust UAV for Impromptu Networking. It's just a clever way to make Bruin into an acronym. The goal of this competition is to create a drone which will hover a 10-pound payload for an hour. And the idea is that that 10-pound payload would be a communications package, allowing first responders to communicate over an LTE network in remote areas. Think of like firefighters responding to a fire in a remote area where you don't get good cell service. So it's sponsored by NIST. We're drawn to it because it's a really ambitious project. Not many college teams are working on it. At this point, there are 8 submissions remaining, and I think 2 of them are college teams. So our solution to fly for that long is we need efficiency, which comes from the X8 configuration, which you see the stacked motors. And then we also use a generator because gasoline is just a much more energy dense source. So allowing this, with all this, we're allowed to fly for approximately 90 minutes. We've flown this drone, but not with everything all at the same time. Last weekend, we were trying to do our 30-minute test flight, but we had a crash, unfortunately. But we're very confident that we will be able to fly for an hour plus, given the June 1st deadline for the final part of the competition. So those are the projects that we're working on. And then if you go to the next slide, you'll just see reach out to us, website, emails, anything you might want to ask us about or learn more about. Always happy to talk.
Cool. Thank you for your presentation. That's everything we have. Our contact information is there too. If you have any questions about any of the projects, feel free to also just email AIAA and we can get you in contact with all our other clubs. And I think, yeah, that's it. We are on time. This used to be like a 30-minute presentation, but we've nailed it down to 15. So yeah, if anyone has any questions, feel free to ask. And if not, I think we're good. Let's stop sharing.
Yeah, very good. Thank you. Thank you, Oliver, Lindsay, Paul, David. Excellent presentation.
Thanks.
Yeah, thank you. Yeah, thank you so much. Yeah, you see Mr. Gooden give a very good positive comments. Very good. All right, so we're on time. So next it will be Cal State Long Beach. So Diana, Ian, you ready?
We are ready. We'll share
Yes,
now.
we're ready.
Okay, go. You can get started. We'll start spotlight you, so we can get started.
Thank you.
Oops.
Okay.
Okay.
So anyone start presentation, we'll add them into the spotlight so people can see them.
Okay, perfect. So hi everyone. We're the Cal State Long Beach AIAA student branch. I am one of the co-chairs, Diana. I'm also joined by my other officers. If you guys want to introduce yourselves real quick.
Yeah.
Hello, everyone. My name is. Oh,
Sorry.
yeah. It's okay. Hello, everyone. My name is Ian Clavio. I'm the other AIAA co-chair at Cal State Long Beach.
I'm Eric Graham, the ambassador for AIAA at CSULB.
Hi everyone, I'm Monica and I'm the secretary.
Hi, I'm Nanette Perez and I'm the outreach coordinator.
And I think we have one more.
Hi, my name is Alex Uribe, and I am the ASB representative for our chapter.
Cool, thank you. And then we'll go ahead and present to you guys now.
Okay, so our mission for AIAA at CSULB is to advance the arts, sciences, and technology of astronautics and to promote the professionalism of those engaged in these pursuits. So we encourage original research, student projects and competitions, professional development in multiple avenues, and then of course the education in engineering and science, which can be a multidisciplinary front. Next slide, please. Okay, so this is our current board for AIAA at CSULB. So all of our contact information is right there. So feel free to grab the email address if you need to contact us about anything. And our channels are always open. And then I'm going to turn the slide over to Alex Uribe for the next slides.
Awesome, thank you. So what is it exactly that we do as an AIAA chapter? Well, first and foremost, we provide networking opportunities to all of our students in our virtual general body meetings. These GBMs range from guest speakers from various engineering companies to professional speaker panels, as well as resume and interview workshops for students interested in gaining internships. We also provide industry tours both before COVID and of course virtually. And these tours have included Northrop Grumman, Boeing, Virgin Orbit, also including labs on campus, such as the Solid Propulsion Combustion Lab. We also provide opportunities for students from different backgrounds to gain hands-on experience and leadership skills in our student projects and other AIAA professional events that we'll see later. Maybe we can get the next slide. Awesome, thanks. And here are just a list of a few examples of events that we've held both in the past and coming up. During the fall semester, we had a virtual job fair with Northrop Grumman, as well as guest speaker panels from both Relativity Space, SpaceX, and ULA, which was an awesome experience. We also had resume workshops with Fred Lawler from Raytheon, as well as a resume workshop with Relativity Space and Kushbu, leading up into the spring semester. In the future, we will have aerospace speaker panels with more companies, including Blue Origin and Northrop Grumman, and another guest speaker from NASA JPL.
So AIAA Outreach caters to the community as well as the elementary, middle, high schools, and community college. We not only promote aeronautical and astral engineers, but all fields of STEM, including science, technology, engineering, and math. And we're able to do so by connecting with students as they prepare for their futures through their participation. Next slide, please. So with everything currently going on these past few semesters, our outreach has been virtual. So some of the virtual events we have done are lab tours, where we had Dr. Kalman present on behalf of his solid propulsion and combustion lab. This was a great opportunity to expose students to some research that is conducted on campus. And a recent event we have done was a Q&A panel with an elementary school in LA. This was a panel introducing students to aerospace engineering. It was a great opportunity because this was many of the first times hearing about it, which was a great outlet to spark their curiosity and open new doors for their students. I'm done.
Yeah, and in this part of the presentation, we'll hear from both of our student projects, being Ezra and LBA, both work in aerospace research projects, one being rocketry and the other being more aviation based.
Hi, everyone. So ESRA stands for the Experimental Sounding Rocket Association. We provide the opportunity to do research and gain experience in both solid and hybrid. ESRA started off as a solid rocket project, but due to the pandemic, we found it hard to do the whole manufacturing things. I know a lot of our leads graduated and a lot of people had, personal issues going on. So we decided to shift the gears and turn it into a hybrid rocket project. So right now that's what we are focusing on. We are doing some research on hybrid rockets, and we are hoping to join a competition and do some launches for the upcoming year. So our goals for now are to apply and compete in a rocket competition, with our hybrid rocket. And if and when our hybrid rocket is successful, we will be the only hybrid rocket team on campus. So that would bring great opportunities for our members and for students at CSULB who are interested in this type of rocket project. And our team is very diverse and inclusive, sorry.
So I'm going to talk a little bit about the other project under AIAA, which is Long Beach Aviation. So it's kind of similar to Design, Build, Fly. It's a rather new project, but it's slowly growing. We have a good amount of numbers now. We actually have a full team. So you'll kind of see on the chart there, I am the project manager, but we also have our chief engineer. And then we have our 5 subsystems: structures, power plant systems, aero, and stability and control. So we are the only aviation focused project group at CSULB. So we really focus on model aircraft, RC aircraft, but also quadcopters as well. We try to venture out to that. So that is us. And the next slide, please. So obviously, with everything being virtual, we've kind of had to shift gears, but still are rather pretty active. So what we do is when we have our general body meetings, these are all virtual, but we'll focus on having seminars and workshops, whether it be in learning software or computer-aided design like SolidWorks, and then also just overall general aviation topics, and even inviting pilots to come and talk. And then we also have individual subsystem meetings. So the leads for those subsystems, they will host their own meetings dedicated to either workshops for their subsystem or whatever they're working on for the DBF competition. So yeah, this is LBA's first time entering the Design, Build, Fly competition. So it's pretty exciting. And so we submitted the design report, and now we're currently building, and we'll begin testing. Similar to kind of UCLA, we are just building with whoever has a 3D printer, building the parts and kind of assembling it at homes and bringing it all together, and then in the end fly it and submit a video report. So look out for that.
I'll be talking about one of the biggest events that AIAA which is organized this year, and is the regional. It's have to aerospace engineering and compete for various cash prizes. These conferences also include exciting opportunities to network with professional students from other schools in the 6 area, as well as manage a project from start to finish. The last time Cal State Long Beach has ever hosted this type of conference was in 2009. So it's been more than a decade since Cal State Long Beach hosted this conference. So we were pretty excited to host it for this year. And this conference has been there every year since 2000. So we regional student conference. We were confirmed for 3 keynote speakers joining for our dynamics consultant, Charles Vano, a retired United States Air Force colonel, and Dr. VA, who is a senior research engineer and professor at Stanford University. Some of the things that you expect at our conference are student presentations from many schools in the Region 6 area, which is the west side of the United States. We also prepare career workshops, social night, virtual tours, networking, and a virtual career fair. And this is all attentive, and we're planning more events and workshops in the coming days. So this welcome everyone.
Sorry, Ian.
Is still open for AIAA.
It's kind of cutting off, Ian.
Yeah, you can try to turn off your camera, save your bandwidth.
Can you guys hear me?
Yeah.
Much better.
No, you sound
clearly.
Picture. Yes.
Okay.
Diana, can you hear him?
All right. So
yeah, way better. Thank you.
Okay. All right. So if you guys didn't catch what I said past couple minutes, we have many plans for a student conference, which includes our virtual workshops, a career fair, and a couple of virtual tours. Again, everything is tentative, and we'll be providing a schedule in the coming days. Here, talk about against an open AIAA national member, and our conference is going to be Saturday, April 3 and Sunday. And on top of that, we will also include virtual networking, and that will happen on Friday. Presenting a research paper in our conference. The manuscript deadline is due tonight at 11:59 p.m. And for those that still have yet registered for our conference, our registration and refund deadline is on Friday, March 19, less than 2 weeks away. And some of our notable conference sponsors that helped us organize for this event are Airjet Rocketdyne, Space Dynamics Laboratory, Aerospace Corporation, United Launch Alliance, and the United States Air Force. So we're open that wants to organize or any help in need for us. We're looking for recruiters for the virtual career fair, and they can be from various industries, companies, and organizations, from laboratories, aeronautics, astronautics, mechanical properties, and many more. So if you're interested in participating, you can contact me and Diana through our AIAA chair email at chair@csulb.aiaa.org. And then for the next part, I think, okay, let me see. Yeah.
Okay, I don't know if anyone has any questions on that because I know it got kind of cut off. But hopefully we will see you guys at the conference. If not, somehow stay connected. But this is kind of, so just in summary, how we have transitioned from in-person to virtual and still staying as an active branch with the events we're trying to provide and by hosting the conference for the first time since 2009. So yeah, if you guys have any questions, please let us know or email us. And thank you, Ken, for having us.
And I'll be putting in the website in the Zoom chat, so you guys can take a look at that, which will include more details on what to expect in our Region 6 student conference this year.
Thank you.
So that's all we have. You can scan our QR codes to get in contact with us. Do you guys have any questions?
Probably running short on time, we know, Ken. So.
Oh, no, don't worry. We'll make it up. So thank you so much. It's really amazing, wonderful thing you're doing. Thank you so much. And this is a great opportunity, to show the public what the AIAA student branch has been a wonderful job, and to show that you rising stars and the AIAA support for you all. So thank you very much again. So stay with us and with the program today, and best wishes to the student conference.
Thank you.
Cool. Okay, so next,
thank you
so much. So next will be the USC student branch. So the host for there is Ava. So if you turn on your video camera, we can spotlight you and gradually pull your team up.
Hi, good afternoon. Can you hear me okay?
Yeah, great. Good to see you.
Awesome, good to see you too. Let's see if the Zoom powers that be will let me share my screen. Are you able to see a title screen that says USC RPL flight on?
Yes, fantastic.
Perfect. Well, good afternoon, everyone. My name is Ava Bedi. I'm from the USC student branch of AIAA, and I'm here to talk to you about one of our student design teams at USC, which is USC Rocket Propulsion Laboratory. We were founded in 2005, and we consist of primarily undergrad students passionate about rocketry, with our founding goal being to become the first undergrad team to make a student designed, student built, student flown vehicle, which would pass the Kármán line and reach the boundary of space. We've done so with our vehicle Traveler 4 in 2020. And so our goal is to move from a space shot to a space program, move towards internal and commercial customer payload integration, and for the development of our bread and butter solid rocket propulsion systems, as well as our liquid propulsion systems as well. So we are by USC RPL for USC RPL. We heavily focus on giving students hands-on design work starting from their freshman year, and we love to fail fast and fail forward. So we want to iterate frequently, go through R&D relative to analysis, propulsion, avionics, to make sure that every year there's some measure of productivity that we can gauge ourselves and look back towards as a metric of improvement. So we do develop our space shot class solid rocket propellant motors, experimental subscale propellant motors, and we're currently in the process of developing our liquids program as well. And we emphasize design, manufacture, test, integration, and execution. So I'll be telling you about a little bit of the subsystems we have featured at USC RPL and what they've been working on in the interim. So the people come first, the rockets follow. We emphasize building the people who build the rockets. We're not just here to build systems, we build the people who will build the systems in industry and academia. One of the projects we've completed in the past year and a half or so is Traveler 4, which accomplished a founding goal of the lab, which was to send a rocket to space. So it achieved an apogee of almost 340,000 feet and had a max Mach number at almost 5.1. From there, we did achieve our goal, but we got good data from both an avionics and manufacturing perspective. There were definitely changes to the vehicle which need to be made for future space class attempts. And we're proud of, as a team, that we were able to just push this rocket over the finish line and be able to iterate on it further. We've also, in the interim, flown Poise, which was, I believe it was flown in January of 2020, so just before we all went under lockdown. That was an experimental vehicle which dealt with extrudable propellant formulation. Our goal there was to increase the density and lower viscosity of our previous propellant formulations in order to eventually build up to the capabilities of developing a case-bonded vehicle. It also included R&D relative to separate deployment for recovery, a black box integrated test bed for our avionics team, and we also streamlined manufacturing of our carbon phenolic nozzles as well. This is the vehicle here, and it was flown at MTA, and I'm sure a lot of you will recognize the stand right here. So this is what we've done in the past. There are things we were doing in the present and definitely actions we have for the future. So for Dome Piercer, that's our mascot for moving from a space shot to a space program. We're targeting the highest amateur altitude ever, and it's the first ever USCRPL payload integration. We've simulated an apogee of approximately 430 K feet, although we'll likely revise that number as we get further along the design. We're excited to see where this goes, and I think the most important thing to note here is all of our successes as well as our failures of previous space shots have definitely fed into the ideation and design of this vehicle, which brings to mind our ethos of failing fast and failing forward. If you can see the text in this firing shot here, you can see Graveler 2 on the side. Graveler 2, which was fired during my freshman year, at the time was the largest amateur composite case static fire ever. But we don't want to leave records back in 2018. We want to keep making them. And iteration is great. So we want to, again, have a set a world record for the largest amateur composite case static fire in history. This will test the motor we want to use on Dome Piercer and give us a better idea as far as how hard can we stress our case design as well. In addition, we also have a sophomore junior design vehicle. So in order to prepare them for space shot design, manufacture, and launch operations, we'd like to give our younger classmen a vehicle they can practice their manufacturing techniques on. So the name's Bond, Case Bond, because this is a case bonded vehicle. So the solid rocket propellant ideally is cast directly into the case rather than first in segments and then integrated into the case. The idea being that you're taking advantage of the volume you have in the case, lightening, replacing the hardware mass you would normally use for a integrated solid rocket motor with just more propellant. More propellant is more thrust, which everyone likes. We are also making our first foray into liquid rocket propulsion. So we are developing Freezer Burn, great name, which is a biprop liquid test stand, which is supposed to help us test an engine that'll help us launch to about 30,000 K feet. We plan to work with LOX Kerosene in the future, and this is fully student design, manufactured, and ideally built once we get to be in person. We plan to participate in BAR's $1 per foot challenge, and we plan to scale this up to a space shot down the road. This is especially enable us to network with folks in industry regarding their advice in dealing with liquid rocket propulsion engines and test stands. So while nascent, this is very exciting. I'll quickly go through our sub-teams. We do have an operations sub-team, which helps us focus on lab safety and compliance because health is number one. They also aid us in launch and static fire planning, recruitment and retention, as well as university relations. Propulsion, which is the team I head, helps us light motors safely and effectively. So if you like to light things on fire, this is the place to go. This team especially has dealt with some major R&D changes in the past 3 years so that we get to the point where we can develop head-end motor ignition, case bonded development, and finical technology. And we also support analysis, integration, and testing for our static fire and launches. Our analysis team analyzed component behavior, optimized performance, and developed models for parts such as our bulkheads, graphite nozzle carriers. The not so great thing, as I'm sure everyone can attest to in the pandemic, is it's very difficult to be allowed to be able to manufacture in person. The great thing for our teams is teams like analysis have really come to shine because all the work can be done on the computer, right? And having access to Siemens NX or ANSYS or other softwares that allow you to conduct static structural analysis or thermal analysis helps students develop the skills they'll want to use in industry. We also have manufacturing. So although slightly dormant during this pandemic time, this does give students the ability to handle materials, metal, as well as composite structures that they'll be able to manufacture and lay up in person. We do have a recovery team, which designs and builds a nose cone deployment system. So you can see an example of one of our tests here. Our recovery team uses a custom off-the-shelf CO2 ejection system, but they've currently been working on their own R&D because we like as many things on the rocket to be student-made and student-built as possible, right? Because that's how we learn. So they're dealing with a pyroless recovery design in order to initiate ejection of the nose cone from the airframe. Our DAC team collects pressure, thrust, and temperature data from static fires. They've been having a wonderful time with our liquids program as well because their work has increased exponentially. So this also allows a great way for students who don't get necessarily the skills they will need in industry and class to be able to exercise their muscles in a real life condition on a student design team. Our avionics team has the goal of collecting data from the rocket during and after flight, which includes a finite stage machine, data recording, as well as sensor drivers. We design and lay up our own custom PCBs, which provide altitude, dynamic sensing, telemetry, and recovery deployment. They're working on a myriad of R&D projects, and they would certainly like me to note that this odd structure that you see here actually allows us to integrate more of our avionics structures as well as recovery hardware. So instead of the typical square PCB bed that you might see, this actually allows us to fit it a little further up into the nose cone, gives us more payload and recovery base space, which makes the rest of the team happy. There's the R&D team, which contains everything. There's 13 active projects related to lighter case designs, a custom composites cutting table, pyroless design, finical and case bonded technology, vacuum casting technology, pancake PCBs, eventually metal fins with metal leading edges down the line. Projects typically have a life cycle of 1 to 2 semesters with a budget of less than $5,000. The point here isn't necessarily to develop something that's perfect. It's to prove the governing laws of physics that make you think you can complete your project, with the goal being ideally to put your design on a vehicle within your time at RPL. The simulations teams allows us to size rockets, optimize our fin geometry, and select our motor geometry, as well as track vehicle measurements over our design cycle. They help develop custom post-flight analysis hardware and help us reconstruct the flight of our rockets from recorded data and document results. This is especially important whether or not your rockets fail to land and be recovered. So whether or not your avionics unit is able to be recovered helps. Like, sorry, I'm stuttering a little. I'm trying to say simulations has been especially required and needed in order to be for us to be able to define our flight paths moving forward. And given that we've been relying them more and more now that we're all online, I foresee them being a more powerful team coming into the near future. And to finish everything off, we need people in order to build the support systems we use. So the production systems team helps us develop and maintain the tools that we use to communicate in labs. So the people who tend to our Discord, Confluence, and our custom in-house ordering system and inventory suite. They're the team that we go to for support, and they are very dearly needed. So unfortunately, many members of the team couldn't be here today. It's certainly more than me, and it consists of years of students and alumni and professors who have helped us be able to develop our technology to where it is right now. So if you're ever interested in talking or just saying hi, my USC email is here, and USC AIAA's email is here as well. So thank you, and flight on.
Yeah, wonderful. Thank you so much. Great job. Excellent. Keep doing the great work. Really appreciate. So Randy, do you I think you want to say something?
No, that's it for me. Just Ava.
Oh, okay. I thought you were going to say something about your branch in general.
No, we've pretty much been up to the same work that everyone else has been. We've had various lecture nights, things like that. But today we just really wanted to highlight the wonderful work that RPL has been working on. Yeah,
thank you, Randy. And actually, everybody who didn't know, actually UCLA won the AIAA DBF contest, the first prize last year. So they actually made a representation already with us in September. So it's fantastic. So really, thank you, Randy, Ava. Really appreciate. Wonderful job. Really appreciate. Keep the good work.
Yeah, thank you for having us, Ken.
Thank you so much for being here today. Appreciate it. So anybody from UNLV here today? Yeah, I contact them. Unfortunately, UNLV people, they say their project this year, they kind of impacted by the pandemic, pretty much. But they actually managed to provide an article, and they want me to say hello to everyone. I'm going to show that they have a couple of pictures. To everyone to share their excitement of there. Where is that? Yeah, here. Okay. So, all right, just give you a second to show. Okay, so this is their the group pictures in the article. They are the third place last year. After UCLA and another school. And so instead of making a presentation, they actually provide us the article, which are going to be posted on our AIAA newsletter. We have article for USC, the first prize last year already. So it's the UNLV people has been kind of hampered by badly by the pandemic. So so their leadership is Sophia and Jet. So they have been trying to regroup within the pandemic. I think several of the members here, they actually have graduated and went on to work in the industry. Emma Chow, last year he won the best presentation, and a couple of people. So they were happy. We are working on the project, and they were proud to be part of AIAA. I think some of their students actually work on some kind of nuclear power propulsion with Los Alamos, and she also make a presentation, I think that October last year with us. So we are trying to engage individual from your branch and also as a group as much as possible, provide the support for you all. Yeah, one thing, just look at what you have been presenting is just fantastic. They're just amazing test, equal to any professionals or even better. But at the same time, because every year we do this every year to have you ever gather together to try to see if there's something more we can provide, but also as a get together and to show the public what AIAA student branch has been doing. So even though we have been doing wonderful job and we have here and there and the effort, but this is a great opportunity. More people, people pay attention. They told us, wow, I mean, individually you do a lot of great job, but I think people didn't realize when you went out, piece by piece, one by one or something like that. But when you all get together, and we got several comments, so they never realized, actually, they actually didn't know AIAA had student branch doing great jobs. But because you get together, you show the, people, you have a lot of, branches and students, they notice, they pay attention. They said, wow, I mean, this is really cool. AIAA is, student branch, wonderful job, and they start to pay attention. So it's good, the branches, once in a while, annually get together. Of course, Region 6 is doing the paper conference, so we are not trying to compete with them. It's actually to complementary. We are more like a get together, give a chance to network, help a career, and the paper presentation is more for publication. Although we can do that as article, but it's not the headquarters thing. Yeah, so really fantastic, great opportunity. We are ahead of time, but to just say something on behalf of UNLV and just let you know they are trying to regroup. They are hoping to participate in a regular event and also next year's gathering, get together for the student branches. We look forward to hear from them, and if some of people graduating this, you might see some of them from this the UNLV branch. Officially, let me explain, UNLV Las Vegas section in general, we are called Los Angeles Las Vegas section, but actually Las Vegas is supposed to get independent. It's called the Foster chapter. So AIAA has this called the Foster chapter. So they are recruiting members there, and at some point they will kind of be on their own. But we're being together, operation to work together. So in a sense, so if you have any question regarding to the education, liaison, Kushbu, Ms. Patel was a good person to contact. I am the event program chair, is helping logistics to pick people together, have social event, professional events. So if any question, please let us know. So I think we have good in time. So we are back to the professional speaker. These are to inspire, everyone, for what people has been advancing rapidly in aerospace. So let me see here. So our next speaker will be Dr. Nahum Melamed. Yes, welcome, Dr. Melamed. So happy to see you. It's so exciting. Oh, can I hear you though? I think it's, remember the microphone. Remember last time, there's a microphone. Can I hear you? If you have a cell phone, you can use the phone number to dial in and keep the video there. No, still cannot hear you.
Can you hear me now?
Yeah. Very good. Beautiful.
Okay. Yeah, I had to enable the microphone on my headphone.
Okay. So let me just briefly introduce you, but you are welcome to self-introduce. So quickly, Dr. Nahum Melamed is a AIAA distinguished lecturer. He's a project leader in aerospace corporation. He's received bachelor science degree and master degree from aerospace engineering from Technion, Israel, and a PhD in aerospace engineering from Georgia Tech. His expertise include orbital mechanics and optimal guidance. His key activities include planetary defense from near-Earth objects, space debris mitigation, and flight software validation. He leads a collaboration with NASA's Jet Propulsion Laboratory developing physics-based web NEO Deflection App, or NDA, to design NEO deflection missions and gain insights on the challenges involved. This includes descriptions and tutorials that are necessary to interpret the data, supports planetary defense conferences, workshops, and exercises. And it's available online. Please visit there. It's very, very fun and exciting. And then they keep updating it. Dr. Melamed served on planetary defense conference and planetary defense exercise organizing committees, giving talks to these venues and instructs a planetary defense class at aerospace. And if you remember the first speaker, Mr. Barnes, he was talking about the ancient dinosaur, the flying birds actually got extinct. That's a very important thing for Dr. Mena's research. You know, we don't want to be extinction. So this, welcome, Dr. Melamed, go ahead.
Thank you. Thank you so much. Can you see my screen?
Yes, very handsome picture.
Thank you. So welcome everyone. Very inspiring set of talks. I learned a lot myself and got inspired learning about developing people who develop rockets and develop satellites, and about regenerating electrical airplanes and looking at what the teams are doing. Really fantastic work. I'd like to present some of the work that you could be doing in the different organizations that you might be interested in. The area which is my personal area of passion is something that's called planetary defense. I'm going to do everything here online. So everything here that you see is basically on the web, and you can actually go and visit those websites on your own and explore the topic. So I've been with aerospace, the Aerospace Corporation, for 18 years now. And you can read about me. Thank you, Ken, for the intro, which was a very good one. So let me jump to the next. What we are doing on planetary defense, we are collaborating with NASA. NASA is the main organization in the US that deals with the topic of planetary defense. So I encourage you to go and visit this website. It's a fantastic website with a lot of truly interesting information about asteroids and about the hazards that would come from space. For those that don't know what is planetary defense, go visit the frequently asked questions part, and it will tell you what planetary defense is. And it's basically those kind of things, finding and tracking those Earth objects that would pose a hazard to our planet, and characterize how big they are and how fast they move, and where they could hit and what sort of damage they could inflict. And also, what can we do in case we are faced with an object that is on a collision course with the planet? So we are going to do a reality check soon, but this is a fantastic website to go visit and learn about those different activities that are done both domestically and internationally. Locally, here in Southern California, you may be aware of Jet Propulsion Laboratory, JPL, which sent those fantastic missions to Mars and to the moon and to planets and moons of planets, and also to missions to near-Earth activities. They have a fantastic website that's called CNEOS, very cool name, right? C Near-Earth Object Studies. I encourage you to go visit this website. It has variety of useful information, both again domestically and internationally. And we are going to explore this website a little bit. We are actively collaborating with NASA JPL, and I'm going to show some of the things that we do on that topic. As you can see here, there are several tabs that are part of this website. I'm going to explore some of these tabs and see what happens. When an asteroid or a comet is discovered, it could be done internationally, and it is being placed on a database, which is called the Minor Planet Center, managed, I think, by the Smithsonian organizations. And every object is placed there with the best information we have on it. So if you want to find any of those deep space objects that are known to us, it's going to be on this table here. some of those objects actually impact our planet. Here is a map of the fireballs that was detected by our government sensors. Basically, they look at explosions in the atmosphere and put it on this map. You can hover on each one of those dots here. The size of the dot tells you the amount of energy that this object had released. None of them caused major damage on the ground. Some of them were large enough. We're going to talk about this one specifically in a minute or so. And in the last about 3 decades or so, there had been about 859 entries. As you can see, they are evenly, uniformly spread around our planet here. And these are examples of what can happen to us, how these objects can actually collide with the planet and potentially cause damage. We didn't hear about the majority of them because they either occur over the ocean or in remote desert areas. But when they are large enough, sometimes you can catch a fireball in the sky, hear the sonic boom that it might generate, or the meteor, the light that it might generate in the sky. And that's a cool thing to do. It's being tracked on this map and several other resources. But these are objects that actually have hit us. Let's look at either examples of objects that did hit us. And from Wikipedia, we can look at the consequences of a large asteroid or comet hitting us some 65 million years ago. It impacted in the Yucatan Peninsula in northern Mexico. It created the CSULB crater. Obviously, there is no crater there today. If you were to visit in this area, we'll see no large, huge crater. So how do we know that there was a crater there when the impact occurred? The oil companies are doing exploration from space to find gravitational anomalies to know where to dig for oil at the bottom of the ocean. And they found those circular shapes that are not explainable by any geological activities. And the only way to explain such circular shape in the ground is by the impact of the crater. Recently, they actually dug some material from down below the ground, and they analyzed the material, and they determined that indeed this was the place where a big asteroid impacted our planet 65 million years ago and caused the extinction of the dinosaurs. And this is part of the huge concern that exists with those space objects. So I invite you to go read that Wikipedia page. It's a fantastic page. And one of the interesting things that they have here, besides just animation of how those impacts create those impact craters, is, let's see if they have it, here it is. So the whole thing got started from those Berkeley geologists that went to Italy to study the magnetic field of the world. And he looked at this sediment layer of limestone from many, many millions of years back. And the interesting thing that he found is that there was a layer of ash that separated millions of years below it and then millions of years above it until today. The limestone below it contained fossils of dinosaurs in abundance, but none were found above that layer. So this was clearly an extinction event. They found that the concentration of iridium in that ash, layer of ash, was 600 times more condensed than exists on our planet, nominally. And we know that this type of concentrations exist in objects that come visit us from space. So they concluded that was a proof that, in fact, a big meteor, big asteroid, or a comet caused the extinction of the dinosaurs. So go visit this page, read a lot about it. More recently, about 50,000 years ago, there was another object that, in fact, did hit the ground in our neighboring state of Arizona. It's called Meteor Crater or Barringer Crater. And here is a picture from space, again, in this Wikipedia page. You can read and see additional links to additional materials. If you're planning a visit to the Grand Canyon area, which is in this region here, it's a small detour to come visit this evidence of what these objects can do to us, and also stop at the visitor center and touch big pieces of meteorites that made it down to the ground and read a lot about it. It's a fantastic visitor center. So again, I'm inviting you to read this Wikipedia page as a starter. Here's a bigger picture of the crater itself from the edge of the crater. As you can see here, the desert is largely flat around it, and there is a big, big impact crater here that was caused by this relatively small object, just about 40 or 50 meters in size, about 150 feet across, created a crater that's almost a mile wide. Okay, and then let me go back to where I was there. So we looked at that. And this is how it looks in this area. You can read about the geology, and you can, if you stop there, and you can stand at this observation deck and look at this amazing power of nature effect on our planet. A more recent event occurred in Russia in the year 1908. There was another big explosion in the sky. It's called the Tunguska event because it occurred in the Tunguska region of Siberia. It flattened over 2,000 square kilometers of Siberian desert that looked like that after the explosion. And 2,000 square kilometers is an area that's larger than most of our big cities. If the same event had occurred just 3 hours later, Moscow would have been gone. Today, there are about 11 million people living there. They would be all be gone in an instant if that event had occurred just 3 hours later. At that time, there were less people there, but this kind of events occur several times, if not in a century, in every 2 or 3 centuries. So again, go visit this Wikipedia page, read about that event, which is really probably the most modern event that was witnessed by multiple people. They didn't know what it was exactly. This was before the age of big rockets and bombs. So they figured out it came from outer space and exploded in the sky. There is no crater around it, but it did destroy the forest. Let's see here if there is any additional information. This is about the size of the object. They estimated it about perhaps 60 meters. Today, they estimate it even smaller relative to Eiffel Tower and Empire State Building, which created this crater. So go visit this page. And actually, around 8 years ago, there was another explosion also in the region of Russia. As you can see, Russia is really a big country. It's a big landmass country in the world, so they suffer more than one hit. And that's called the Chelyabinsk meteor. It exploded in this region of Siberia and kind of looked like that. This is the age of dash cams. So this guy was, or this person was driving to work presumably in the morning with a dash cam in the car, stopped at the traffic light. And as you'll observe, there's going to be a large meteor passing through the sky and exploding when it interacted with the atmosphere, creating light that was brighter than the light of the sun for several seconds. Quite amazing event. So all of that is described in this Wikipedia page, which again, I invite you to go and read. Really, really interesting information. It was a very small one, but it did injure about 1,500 people. And that was during the time where they could take a lot of sensor information and figure out the direction from which it arrived. And it came basically from the asteroid belt, which is the region of rocks between the planets of Mars and Jupiter, orbiting the sun, just like we do. And so that's another example of real things that can happen Here is an example where the windows were shattered in the drama theater in that city, which most of the injuries were created by broken glass. And here is an example of how it caused damage to buildings. They were very, very lucky that this object came very, very shallow into the atmosphere. If it had penetrated much deeper, it would have caused a lot more damage and many more casualties than experienced in this explosion, which was a very, very small object. So again, I'm inviting you to go visit this page on the Wikipedia page. And then let's see here, how do I move to the next one? Okay, so let's go back to the CNEOS webpage and see how many of these have been discovered to date. As of literally yesterday, JPL updated their discovery statistics, and we are now at about 25,334 near-Earth objects. Near-Earth meaning they did not impact us. They are not projected to impact us, but they pass just too close to our planet to feel comfortable. So we want to keep an eye on these, looking into the future just to make sure, and also to try to detect some of these into the future to see if any of these has a risk of colliding with our planet. And you can see here the rate of discovery is increasing, which kind of tells us that we are still in the dark ages with respect to where we are on these. Let's look at some of these that have been discovered. The last year in 2020, they discovered 3,000 new objects that we were not aware of. And we were just very fortunate that this did not impact with us, but they did make a close approach. This year, we are already up to 500. We'll see how far it's going to proceed into the end of the year. In terms of looking at the really big ones here, those that are kilometer and larger, these are objects that can really cause global damage and really change our civilization. As we can see, we discovered most of them in the last couple of decades or so, and we are now discovering very few each year. None has been discovered this year to date. And we are monitoring each of these objects because of the potential damage they can inflict on our planet. None of these is threatening in the next 100 years or so. So we are going to leave that risk to future generations of scientists and engineers. Maybe some of you will be dealing with this type of planetary protection, but it's not something that is super urgent at this point. We just want to keep our eyes on these objects as they are discovered, sprinkling in every year. We are now more concerned with those that are medium size because we are finding probably in the range of 500 to 600 of these every year. And each of these could destroy a continent, could destroy a large country instantaneously. These are large objects with energy that is thousands of times or millions of times more than any atomic bomb that was developed by humans. It doesn't have the radiation effects, but it has the destruction effect. So we definitely want to keep an eye on this. Okay, let's move forward. So let's see what's going on around our planet in real time. This is a snapshot of what's going on around our planet today. Today is March 6th. We have an object that is passing by our planet at a distance of about 7 times the distance to the moon. It is 30 to 70 meters in size, which is the size of the Tunguska object that we saw just a few minutes ago, with the potential to destroy a large city anywhere around the globe. We are fortunate that this object, which was discovered this year, it was discovered earlier in 2021, was just a close approach and not an actual impact. But a lot of these are just too close to feel comfortable, in terms of what can we do about those type of objects? What kind of action, mitigation action we could mount if we, discover an object that is potentially on an impact collision with us. For example, let's look at this one. This one is going to pass near us in November this year, later this year. It was discovered perhaps a year or so ago, and it is fairly large. It's 50 to 100 meters in size. It could destroy a small country like France or Texas instantaneously. And it's very close. It's just 1.5 times the distance to the moon. You know, it's like you have a feeling that we live in a shooting gallery looking at this. Let's look at some interesting information about this particular object, which is called 2019 XS. So it was first observed in 2012. How can it be that it was observed before it was discovered? And the reason is because all of the nighttime pictures that are taken by telescopes are archived. When a new suspect object is discovered, they go back and dig into those archive pictures to see if the object had sort of, they call it a pre-discovered. And it was actually pre-discovered in the past. This is very important because this information helps us nail down the orbit of the object and any risk of future collision with our planet with this object. It basically just adds to the database of measurements that we have on the object. So those people who like to calculate orbits of planets and spaceships and rockets would love this type of activity to calculate the orbits of those objects. So how do we deal with that? This is an object that was discovered just maybe 6 months before a close approach, which could be a potential impact. To help out how to deal with this type of situations, we run international planetary defense conferences. And this is an hypothetical impact scenario that are designed for the different conferences that we held over the years. PDC is the Planetary Defense Conference. The next one is going to occur next month virtually. And here's the scenario that was concocted. Everything here is obviously hypothetical. None of this is real, but it is very realistic in terms of what could happen with an object similar to what we have seen a moment ago on the chart. So they pretend that this kind of object would actually impact with our planet, and we'll run a scenario over the 5 days of the conference with discussion groups and panels and expert opinions as to what we could do about it. And so again, I'm inviting you to visit this fantastic JPL page and read about it. As you can see here, when the object is discovered, the likelihood is evenly spread across the planet for any location to be impacted by the object, just because we don't have enough measurements that will tell us exactly where the object would be impacting, if it would be. Follow the conference. The conference is going to occur at the end of April, and it's going to be broadcast live. So keep an eye on that. It's going to be a fascinating conference to follow through. Okay, now let's see here. How do I move to the next one, which is this one? Okay. I went back to the table of close approach, and what I've done, I filtered out those objects that are really large and made a very, very close approach with our planet in all times. As you can see here, all of these are in the hundreds of meters in size, even kilometers in size. These are literally global effects, And they all passed less than 1 times the distance to the moon, starting from 1914, going all the way into the next century or two. So as you can see, we have been very fortunate so far not to be impacted by any of these very, very close approach by large objects that could change life on Earth, literally. But we do want to keep an eye on these large ones that are passing in the next decades and centuries. And a very interesting object is this one that's going to pass at just 10% the distance to the moon. This is the altitude of our satellites. It's going to pass below our satellites in the sky and potentially be visible without any optical aid. You might be able to just see an asteroid passing above you during the moment of close approach. It's going to occur on April 13 of 2029. So just 8 or 9 years from now, keep an eye on that. It's going to be in the news for sure. An impact with Earth has been ruled out, but it's going to be a huge event in the news. There's already missions that are planned to be sent out to this object to monitor it and watch it. So this is going to be a very, very nice event to follow through. And again, go visit this website and just do your own exploration to see what's going on there. So if an object had been discovered on impact with the Earth, what could we do to mitigate that situation? So in collaboration with NASA, we developed the so-called Neo Deflection app. It's an application, it's a simulation that will help us to understand how to deflect asteroids. In this case, the asteroids that are loaded to the tool are all virtual, all simulated objects, but we have orbital mechanics built into the tool. We have launch vehicle performance built into the tool. And what we can do here is look and see how any of those hypothetical objects that one is created for the upcoming conference and the other ones just exist on this tool. You can pick any of these and it will tell you the orbit of the asteroid, the orbit of the Earth, and how to access that asteroid from the Earth via a launch vehicle, via a rocket and a spacecraft. All of this is built in the tool, and what you typically would do is that you will use our existing launch capability to move this impact location from inside the red capture circle here to outside to avoid an impact with our planet. As you can see here, currently the object will impact with our planet, but also the geometry currently is in favorable of being able to launch a rocket and deflect the object, the asteroid or comet. In order to do that, we need to design a mission. And you could be a mission designer if you like system engineering and if you like to design orbits and or you like rocket science. This is the kind of tool for you. You could maybe change the times at which the mission will be launched. As you can see here, I found the solution. So now I was able to move the impact location from the red dot to the green dot here. Somebody is going to complain, that's not good. We want to move it outside of the Earth. But that's where orbital mechanics kicks in, and we were able to calculate the trajectory in space that will connect the Earth and the object via a transfer trajectory.
Actually, Dr. Melamed,
yes.
We have like 2 or 3 minutes left.
Okay, very good. So to do that, you might select another rocket. And with 2 rockets, you can see that now we're able to miss the Earth. And that's how you might design a mission. To help out with this, Aerospace Corporation has recently created a website, which again, I invite you to visit. You can read about educational tools for STEM outreach, which was one of the topics, I think, from the UCLA team. You can read about how we engage with STEM outreach. You can look at videos that we created. You can look at lesson plans that we created, and you can use any of these in your outreach. We also contributed to an IMAX film that's called Asteroid Hunters. The film has been released, but because of the pandemic, it's not in the theaters as yet. But as soon as those theaters will be open, you can go and see the movie, and part of the work that I do is in this movie. I'll be in the movie here, so go to this page and look at this trailer. And then the last item here, let's see here. So there are several activities here that we are engaged here at Aerospace Corporation with respect to doing that. We use artificial intelligence on some of those tasks. And recently, we have developed an upgrade of the tool here, which is in this other aerospace website here, where we created a teaming version of the app. So this is, we added an ability to do asteroid deflection contests Everything here is identical to the JPL version that you've seen a moment ago. But if you turn on the teaming mode, you'll be able to conduct a contest by selecting a team, either from an existing name or type in your own name, and then set up the campaign limits by saying how many launch vehicles are available, maybe 2 of these and maybe 1 of that. And the asteroid was discovered perhaps 8 years prior to impact, and conduct other things here. You can set those limits. In this case, let me set 1 minute for the contest. And now the clock is kicking. Different groups here have the mission to move this green dot outside of the red circle. So they're going to try to change those times, just like we've done here with emission design. And when they do that, they might hit a roadblock here that doesn't work. They might have to add another rocket to that, and perhaps, and with 2 rockets, we see we can do it. We develop a performance metric, which will be different from team to team because there's thousands of combinations here that are possible for designing a mission. And the winner is the team with the highest performance metric. So go visit this website here. And finally, I want to say that Aerospace Corporation is hiring both interns and new graduates, experienced positions as well. I think for this year, interns is too late because all of the positions have been selected. But if you'd like to be considered for next year, go visit our career website here. And so this is a picture of our interns from the last few years. They work on different areas here. Let me show you I think if you go here and hit the career page, you'll see the different disciplines that we are looking for. Pretty much every discipline: electronics, information systems, system engineering, vehicle system, which are launch vehicles, satellites. Also, we are looking for scientists, chemists, physicists, to work in our laboratories and develop our business. If you want to manage a project, you can go to the program office and manage a group of engineers and scientists. And we are looking for students and recent graduates. So by all means, go and visit our careers page, see what requisitions are currently open. And if you are interested and available, you are welcome. And with that, I am done. I see a hand up question from Diana.
It was an applause. Great job.
Oh, thank you. Thank you. Thank you.
Yeah, Dr. Melamed, yeah, because I think we're running out of time for the presentation, but during the panel discussion, we have more time, people can ask questions. And everyone, Dr. Melamed is very passionate about, helping the young generation. So you're welcome, to, please join the career panel and also the breakout session, along with, the fellow panelists, the speakers. The Dr. Melamed will explain to you more about the opportunities Aerospace Corporation, and you can get advice from him for your study and career. So stay tuned, and also come back, for the career panel breakout session, and continue to enjoy the next few speakers. Thank you, Dr. Melamed.
Thank you.
Stay in touch.
Thank you.
Okay, so yes, so we are going to switch to Mr. Bill Kelly. So let me see.
Okay, I unmuted everybody out there. Can you hear me?
Yes. Can you would you like to show your video so we can spotlight you, or you prefer to stay?
No, it's all right. I don't mind people looking at me.
Okay. No problem. No problem. Okay. So Bill is is a great aerospace engineer. He's recently retired from Georgia Rocketdyne. He's a senior member of AIAA. And he retired after 19 years of service, plus 26 more years at the other great aerospace corporations like Macquarie, Vaco Industries, and the power companies, Babcock and Wilcox companies. He was recently he was our treasurer last year for the section. His experience at Babcock and Wilcox includes system design and the startup testing of large steam boilers and a nuclear reactor, like 3 Miles Island, etc. His experience at Macquarie includes small rocket engine and ramjet testing, nest, etc., and the naval weapon system development. His experience at Aerojet Rocketdyne includes large rocket engine system engineering, assembly and testing, RS-84, J2X, RX-25, and the system engineering for MMRTG. This is very, very exciting. He'll tell you more about it when you get a chance. And many space missions are using it now, and it's been a long time. He holds a Bachelor of Science in Mechanical Engineering from New York University and Bachelor of Science Nuclear Engineering from University of Virginia, and a postgraduate certificate in Aerospace and Aeronautical Engineering from UCLA. So he's a UCLA alumni as well. So let's welcome Mr. Bill Kelly. Go ahead.
Ken, I seem to have screwed up my, oh, there you go.
Oh,
can you see it? Decrease the size?
Decrease the size.
Looks a little big.
You mean the screen?
Yeah, the screen.
Let me see if I can do. Let me see. Well, I think what happened is this is actually control from your end. You should be able to pull, select the views, and if you choose the speaker view, then you should be able to see, make adjustment for the screen.
Oh, fit to window, yeah. All right, hang on here. I'm getting close.
Okay.
There we go.
Sorry for that.
And
try hitting Control minus.
I'm sorry, what?
Try hitting Control and minus.
Control minus.
And the minus sign.
Okay, I think, can everybody see that?
Why don't you advance by one slide? Okay, there you go. We got a full slide there. Is that what you want us to see?
Well, I wanted to start in the one before. Yeah, I have a few introductory things. Yeah, this is Bill Kelly, and I'm going to talk a little bit about resumes and interviews based on my experience and what you need to get a job and things like that. But also, I have a few remarks about what it's like the first day of work. I've actually collected some data by asking a new employee at Aerojet Rocketdyne, what's it like the first day, the first week, what do you do? And also I have a little information about the kind of money that people are gonna make if they get into their aerospace jobs or into engineering jobs in general. So I'm going to have something about resumes and interviews, but maybe some of the other information is more interesting to people. Okay, so next slide. All right, I thought I'd start off by showing my own personal resume and at the size where I think it's most people want it today. Most people don't want to go through 4 pages of information. They want a succinct summary of facts and significant information. So this is kind of what I had in mind. Ken's already gone through my educational experience, my all the paper that's on my walls at home, including UCLA here locally. The work experience has been kind of varied. I've been in the nuclear power industry, which also came back to help me do something later on in my space career, which I'll get to in a minute. Yeah, I was involved in a lot of steam boilers, and I actually spent some time at the 3 Mile Island nuclear plant during their cleanup. I was part of the crew. I finally got into aerospace fairly about halfway through my career by testing small rocket engines, like the station keeping rocket engines for the space shuttle and satellite station keeping engines. Worked on a Navy weapons system development for a time. Then I got into the larger rockets, the Delta IV engine, which is RS-68, and the space shuttle main engine. I also worked on the SLS program which is using the SSME to create the new launch vehicle. They ought to be, I think they're doing the test launch next year. So that's pretty exciting. I also worked in the space electric power area, including programming on the International Space Station. But I also did work on MMRTG, which you may have recognized from recent history. It's the power supply for the Perseverance rover that's just landed on Mars. It's also the power supply for the Curiosity rover, which has been on Mars for years now. And I bring that up because it lets me talk about papers. Part of what you should do or consider doing for your career, for your resume, is getting involved in writing papers, either student papers or other papers. I've done about 10 total between nuclear power and aerospace industries, and they show that you're different. They show that you can write an English sentence, or you're capable of writing technical papers that have value to the industry, and that sets you apart from other people. Engineers aren't noted for their ability to write well. They spend all their time studying technical subjects, and they don't spend enough time, I think, thinking about writing and documenting, and because that's a basic part of engineering, and it's documenting results and spreading information. So that's what a brief resume, a one-page resume, which is what a lot of people just want these days, looks like. At least it did for me in my entire career. Okay, let me have the next page. More about papers. This is the paper that I was the lead author on, which I wrote about the MMRTG. I've also done a presentation on MMRTG on this very paper for AIAA a couple of times. Once done at I think we went to Loyola Marymount University, and one or two other times. So I'm supporting the notion that students should write papers. They should write papers for the experience, and also they're fun, and you get to go to fun places, believe it or not. I wrote the MMRTG paper for a conference in Albuquerque, New Mexico. That's not the funnest place on the planet, but it is fun to go there. And a few other places in the country for various societies, American Nuclear Society and things like that. But the most interesting paper and the most exotic place I went to was a paper I wrote about system engineering for the SLS program. And they sent me to Glasgow, Scotland, to the International Astronautical Congress meeting in Glasgow, where I got to talk about with a bunch of other NASA people about what SLS was going to do for our space launch capabilities from the planet. I think they were trying to sell, NASA was trying to sell the idea to European companies, the idea of using SLS in the future for the launch of big telescopes, space telescopes, replacements for the Hubble and future European space telescopes. I'm not sure that's happened yet, but that was the idea. So I got to go to exotic Glasgow, Scotland to deliver a paper. So let me have the next page. So the resume tips, which I kind of got into in the first couple of slides, there's the usual stuff. Don't forget your name, address, and phone number, because they need to get back to you when they start talking about phone interviews and in-person interviews and repeat interviews. They want to, you might want to make sure they know who you are and where you are. The education, certainly the degrees you have, also honors that you have received during school, like if you're on the dean's list and things like that. Work experience, summer jobs and internships are very important. When you hire somebody, and I've hired people in my career, showing up with an internship that in an area that's valuable to the company you want to intern with is very impressive. It says you're just a student. You're working in the industry already. It gives you a leg up, and that's what you want to do. You want to find something that makes you unique, not just technical either. There are other things you can do that wind up being impressive to people, potential hires. I list Eagle Scout. I know there's a lot of controversy about the Boy Scouts these days, but having achieved an Eagle Scout award still impresses people with your ability to complete tasks and stick to something and that kind of thing. Community service is also important. It shows that you're not just a diehard engineer that doesn't know how to do anything else. It shows that you're involved in the community. Internships I mentioned. Next one is join the USC or CSULB rocket factories. We saw good presentations by USC and CSULB, also UCLA. Very impressive about your rocket abilities, your rocket capabilities, both analytical design and fabrication. It's very impressive that these schools are getting involved with manufacturing, not just the theoretical side of things. So, anybody who's going to any of those schools, join the local rocket factory and get some things done and get it on your resume. It really helps. Of course, we encourage everybody to join or start an AIAA student chapter. You get the opportunities like this to interact with people who have had a aerospace or other engineering career, leaders of the industry, and so it shows you're dedicated. Also, as I said, write a student paper. I believe there is a student paper competition that AIAA has every year. Even if you don't win, write a paper and participate in that, and it shows the company that you have the ability to write a student paper. Also want to note that AIAA rules about writing papers when you get them reviewed by people for a conference are fairly rigorous. Especially about footnotes. Before they were done with me for one of the papers I wrote for one of the conferences I went to, AIAA had me write about 25 footnotes on information in the paper, which I had accumulated, but I hadn't footnoted correctly. So they're going to be on you. Be careful of footnotes. They're very important for writing a paper. So if you're just graduating, don't make the resume 4 pages long. You haven't done 4 pages. I advocate 1 page or 2. I think most people will do that. When you actually apply for a job, these days you're probably going to have to apply online and submit perhaps a resume or some kind of letter, and then hopefully you get a call that you have a phone interview and then an in-person interview. That's the way it seems to be going these days. But again, my advice is keep your resume fairly short. When you graduate from undergraduate college, you haven't done a whole enough to make a 4-page resume. You need to think about 1 or 2 pages. I note at the bottom that I switched jobs about 4 different times in my career. So my resume worked 4 times if you want to evaluate the kind of information I'm giving you here. Okay, next slide. Okay, on the interview itself, if you get in front of somebody, and most people will ultimately want to see if you're worth anything, dress to impress. But you don't need to wear a tuxedo. Don't get too fancy. Engineers are typical in their ability to avoid wearing suits and ties. I started out my engineering career a long time ago having to wear a tie and a white shirt and one of those guys. But these days, don't come in dungarees and sneakers, but dress to impress. My personal advice is don't look bored, even if you are. If they start answering questions, you're always interested in whatever your interviewer has to say and whatever question he has for you. Be prepared to answer the following questions. Why do you want to work here? They want to know, I want you to express some kind of reason why you want to work here. I suggest the answers are, I always wanted to be a rocket scientist. That's the way I would have interviewed if that was my first job. XXX means the company you're working for. You can make the statement that this particular company is an industry leader and I want to work for an industry leader. I also want if you're intending to interview or if you're interviewing for a small company, there's a challenge of working in a small company. It's a risky situation, but you can tell them that at the interview. Also, before you go in and talk to a company, research them, ask good questions like, is there anybody trying to buy this company? That has to do with your livelihood, your future. And so you have a right to know if they're just about to get sold and whatever negative implications there may be for that. You want to know about the price and price earnings ratio of the stock. You want to know the health of the stock of this company for your own personal information to judge if you want to be there. You're going to ask the question, when was your last layoff? Aerospace companies, the aerospace industry has historically been fairly uncertain about longevity. Anymore, that seems to be less of the case, but in the early days of aerospace, there used to be lots of turnover at the aerospace companies. So you want to know that the answer to that, when was your last layoff? Chances are the company is not going to, what are the chances that the company is not going to be around in 5 years? Another question that strikes home at the stability of the company that you're interviewing with. How many employees under the age of 30? I mean, is all their technical ability tied up in people who are just about to retire? Or do you have young guns ready to solve the world's problems? That's an information you'll want to know for the sake of the competition you have for the positions that you're going for. I also found, or I actually believe that I got my job at Aerojet Rocketdyne by asking a question, are you still worried about combustion stability? And a technical question. When you develop large rocket engines, there's a series of explosive pressure distribution tests you do inside the combustion chamber for a rocket engine. And it's one of the last things you do well, not last, but one of the first things you do after you've had some hot fire experiences, test to see if your design has combustion and stability. It's particularly a question for large rocket engines where there's the possibility of more possibility of combustion instability. So not maybe that question, but an astute technical question that tells people you know what you're talking about, or that you have some knowledge of the kind of technical area you're going to get into. Okay, that was interview tips. Next page. So what should you expect working in the aerospace industry? Well, for sure, government oversight for US government contracts. NASA, if you work for NASA, they will watch and watch what's happening in your with whatever contract you're working on, and approve or disapprove decisions. NASA's very big on government oversight. Also, the Aerospace Corporation, Dr. Melamed's company, is used by the Air Force to have a technical overview of Air Force contracts. I interface with those people for the R-68 engine program. US Navy does the same thing to hire civilian contractors. So expect, if you're working on a big contract, government contracts, you're going to get oversight that you'll, so you have to be prepared for that. I've mentioned uncertain longevity. The history of the aerospace industry has included lots of personnel shifting around when large contracts come to an end. This is particularly true of Air Force contracts that supply new jet engines or fighter aircraft or cargo aircraft. There's always a degree of uncertainty about how long it's going to last after the contract that's currently going on. However, those being a little negative, aerospace is about the most exciting technical area on this or any other planet. Imagine working on turbojets and scramjets and rocket engines and airplanes and satellites, and like in my experience, Mars rovers. Never thought I'd be a person who has knowledge of what happens on Mars when I was going through college. There are good salaries in the aerospace and engineering companies. Let's go to the next slide.
Yes, Bill, we have roughly 3-4 minutes.
Yeah, I'm almost done. I'll breeze through these. This is information a couple of years ago about median wages for various segments of the industry, various degrees. And you can see that engineering in general beats any other major as far as what you start out with, or even by mid-career. You can always, if you look at aerospace, they're about halfway down. Starting at $64,000 in 2019, you can expect by mid-career something like $100,000. Next slide, Ken. This also shows that even by the end of your career in engineering, you're talking about mid $100,000 annual salary. So you've made a good decision by deciding to get into engineering. There's good money in an engineering career. Next one. Next, Ken. Okay, so this is a slide I had about what do you do? I asked a person who a new hire at Aerojet Rocketdyne, I asked him to actually record for me what he had done on the first day, first week, and various time periods in the first 6 months of his career. You can think about 4 to 5 hour orientation programs, lunch with managers that introduce you to your team and mentor. You got to spend a lot of time walking around with people that you're going to work with. You got to set up your desk and set up your computer. And at larger companies, they will have you take training courses, not technical training courses, but training in safety, security, proper practices, sexual harassment, and a lot of other stuff. So expect that kind of thing. And every week there are intern socials. He was very grateful for that. Now, one company presentations, you learn about various other sites, if there are any for a large company, what goes on there. Next, Ken. And for the first few weeks, at least this guy who was a stress analyst said that they, of course, learn what FEA, finite element analysis software, they're using, and learn the models that they're going to start using for design tasks for various engine work. He got involved with transient systems analysis, which in which he learned about data acquisition tools, of sophisticated plotting techniques and plotting programs, and he began working on the RS-25 program. In general, there were lots of videos showing a technical process. NASA wants your technical process to be very structured, such that you don't lose technical capabilities as somebody leaves the company. It's always there if you have good process. And you hang around with your mentor to make sure you take advantage of his experience about what's going on here. Ken, next one. I guess that's it.
You're right. That's the last one.
That's the last one, yeah. And I guess we'll take care of questions after everybody else is done.
Yeah, that's right. Yeah, so in the panel session, people can ask more questions.
Right.
Yeah. Thank you, Bill. This is so amazing. There's your information is actually very, very helpful and very up to date. And the student and young people, they will benefit so much, from it. Really appreciate it.
Yeah, not highly technical, just real life staring you in the face.
That's most important.
Yeah, I think so.
All right. Diana says thank you. So Diana, stay, with us, career panel in the breakout. You can talk to Bill directly. And Bill is also a rocket expert. In the past, whenever he went to our student branch, and the student just went up to him, for some advice for their rocket design. So stay with us. Okay. So and our next speaker is Mr. Bawa. He's the president of the LA Gauge. Okay. Yeah, you're here. Okay, wonderful. Hello. So can you unmute? Oh, just a second. No, still cannot hear from you.
It's an icon at lower left. You have to float your mouse.
Let me do this. Maybe I can. Yeah, thank you, Phil. I think maybe you can remind him to. Do you see something pop up if you click that? Okay, it seems to be. You are unmuted, but still cannot hear you. Take it easy. I see you are using the phone, but I need to unmute. Let me try again.
Hi, Ken. Can you hear me now?
Yeah. Wonderful. Thank you, Mr.
Okay.
Bawa.
Sorry about that. Yeah, I had to get on my phone there.
I understand. It's the kind of, but it happened, sometime.
Yeah.
So I'll just quickly, yeah.
Go ahead.
I will just quickly make an intro with the bio, and you're welcome to self-introduce, add more thing. And actually, this is very exciting because you will hear from industry leaders and from a different perspective from the industry. So, may I ask, it's a first name? Sorry, but it's Jyot. Is that right?
That's right. It's Jyot. It's like Joe with a T.
Okay, Mr. Jyot Bawa is president of the AIAA company, a family-owned aerospace and defense manufacturing company specializing in ultra-precision machine surfaces to produce the most complex and tight tolerance hardware required for aerospace and defense industry. Known primarily for his success in machining beryllium, one of the only two major suppliers in the United States, AIAA demonstrates American precision at its best, holding machines tolerance to 40 billionths of an inch and polishing optical components to the billionths of an inch. AIAA is the key supplier for every major defense program that requires beryllium components. For example, they make guidance and targeting system components for F-35 jet, Apache helicopter, Global Hawk surveillance drone, Standard missile -3, nuclear Trident missile, and the nuclear Minuteman missile. Then in 2019, AIAA was the proud recipient of Lockheed Martin Missile and Fire Control Small Business Award for critical support to their programs. Put simply, when companies such as Lockheed Martin, Raytheon, and Boeing have critical and difficult parts that are beyond the capabilities of other manufacturers, they came to AIAA. So this is really fantastic. You know, when I talked with Ross, and I was really fired up. You know, we are trying to have article with event with you. So now the president of the company and he's a Harvard graduate, very good in business operation and management, will talk to us. And please stay, you know, and listen to what we're going to be talking about. Thank you so much, Mr. Bawa. Go ahead. And now you turn it off again.
How's that? Are we good?
Yeah, that's better.
Yes.
Okay. Just, you know, let me know if there's some. It looks like we're having a lot of audio issues, so I'll try to be efficient. I apologize for that. I actually have a few videos I wanted to share, but I think that's some next level tech work in this situation, so I might have to skip that.
You can try if you want. We have some time. You can try.
We'll give it a shot, but I don't want to waste too much of folks' time, and I can surely share and talk to people in the panel discussions if it doesn't work out. So again, thank you for the introduction. I just want to kind of set the stage a little bit of what I would like to bring to the table here, because the presentations so far have been extremely well-rounded and much more technical than I think what I'm going to be bringing, but hopefully it's valuable. So I want everyone who's here to just picture themselves. It's 6 a.m. on a Monday morning. You're walking into a large facility, windowless. You open these big steel doors and you switch on some humming lights, and you see a sea of 5-axis Mitsui Seikis and Mazak lathes. You're walking through, you see machinists all in their coats, starting to turn on the machines. You grab a cup of coffee. Everyone's a little dazed and a little tired, but as you look around, you're seeing people turning on machines, walking inside machines sometimes to set certain components up. And then you sit, and as you're walking through, you look up and you see a very large screen with a plant layout with different color codes, red, yellow, green, across the plant, with part numbers and part names that you know are ultimately going into deep space, into tactical systems, into strategic systems, weather satellites, and even nuclear fusion reactors. No one else can really understand it from the part numbers that you see up there, but you know that when it's green and that part number is there, you are producing something that is ultimately going to be moving humanity forward. As you continue to walk, now you walk into the offices, and the buzzing kind of stops. The smell is a little different. It's not that much of a machine shop, and now you see a lot of engineers sitting glued to their computers, looking at 3D models, having a list of instructions that they're building, and the only time they're looking away from their computers when they're looking down at a specification, a Q note, or a drawing from a customer to make sure that they're looking at the correct data and the correct approach to ultimately produce a part to achieve mission success. And just 10 minutes after that, after seeing all the people on the machines, all the people in front of their computers, your phone just goes off the hook. We're in California. Our biggest customers are all on the East Coast. They're 3 hours ahead of us, and they're now calling you and asking you, where are we with our batch of parts? This is the time that we're going to have the next order coming through. Are you guys ready? Oh, and by the way, our data isn't matching up with yours. We need to get with your engineers ASAP to start lining up the inspection data. And that is a typical Monday in a small business in the aerospace and defense industry here in America. It is an industry I'm very proud to be part of. And I want to talk to you a little bit more about what that is like in detail and why you should consider looking at smaller businesses, suppliers in the aerospace and defense industry, because it's those suppliers who are really bringing the design to life. And that's a very, very exciting and fulfilling trade if you so choose it. So as Ken mentioned before, my name is Jyot Bawa. I'm the president of a company called LA Gauge here in Los Angeles, actually in Burbank, next to Burbank Airport. We do ultra-precision machining of exotic materials for the aerospace and defense and space industry. We're most known for our work in beryllium, and I want to kind of take a quick deep dive on why beryllium is such an incredible metal when it comes to producibility and performance in various environments. So we are one of the very few companies in the country that machine beryllium or the aluminum beryllium alloys. And the reason that is so important and the reason we're using that material so often is because it highlights our capabilities in holding extremely tight tolerances. So when Lockheed Martin, Boeing, Raytheon, Northrop Grumman have an extremely complex part and no one else can make it, they usually come to us and they usually choose beryllium because that is the material that showcases the tight tolerances. And when I say tight tolerances, when it comes to machining, we're talking about 40 millionths of an inch tolerances, plus or minus. And then when it comes to electro-optics and optical polishing, we're talking on the order of about 20th wave. So we can produce metal optics that support weather satellites, targeting systems, and even the NASA James Webb Telescope in deep space. So that's what we do. That's our bread and butter. And what makes it such an interesting environment and something to consider as you look at the sea of opportunities, it's an interesting environment because we provide high value, but ultimately low volume batches of parts to the industry. And that means that when you have a factory with so many different parts changing and the product mix changing all the time, production engineers have a very complex problem ahead of them of figuring out how to make all those parts ship on time with the right specifications being completed. And so when you think about suppliers and the supply chain for these large OEMs such as Lockheed Martin, think about the complexity that they work under if you're an engineer working for them, and also think about the opportunities that are there for you as an engineer, whether you're a mechanical engineer or a production engineer, to solve complex problems every day because the product mix and the environment is constantly changing. If you think about what kind of environment you want to work in, you can think about larger companies that have a bit more stability but are less dynamic. Or you can think about smaller companies that, as Bill kind of mentioned, you want to be asking about their stability, their long-term perspectives. But given the needs and given the limited resources that the small company has, you end up having a jack of all trades approach, a generalist approach to your experience. and you're able to basically cover anything that the company needs. So you could be an engineer, but then you could also be focusing on quality inspection. You can be focusing on contractual notes, or you can be on a machine programming for a particular operation. So it's a very exciting environment, and it's something I really think everyone should consider as they move forward and graduate from UCLA and and the Cal State Long Beach, and USC, of course. Can't forget you guys. One of the other things that I want to mention about working in an environment such as ours is, even though it is a very small environment, it is really fun to look at where our parts ultimately go. And Ken, this is going to be my first attempt to show a video. So let's give that a shot. And again, if it doesn't work, we can just keep on moving.
Yeah, basically open it first and put it on the desktop and use the share screen. There's a share screen button on Zoom and point it to that video screen.
Missile that is launched to take down the incoming missile it only uses kinetic energy. There are no explosives on it. So if you can imagine, it must be precise, because that is all it has to knock an anti-missile, to knock a missile out of the sky. It is incredibly exciting, but you can also imagine incredibly difficult, and requires precision at a level across an entire supply base that is extremely difficult to hold over months, years, and decades of a program. So we're baked into that, and we take that responsibility that we have to heart, and so do our machinists, and so do our engineers. So I just wanted to kind of lay out there for you what the ultimate impact is for any of these kind of jobs, because sometimes it can be hard to see, especially in your first job out of college, to know how you're impacting mission success for our country, and when it comes to other explorations for humankind. The next thing I wanted to tell you a little bit about is the material, beryllium, that we work in, because I think as you look at different suppliers in the aerospace and defense industry, you're going to see that there's a lot of niches that are incredibly interesting and very different. And you have these subject matter experts who are really, really good at gold coating or powder coating or heat treating and thermal cycling. And one of our passions is doing machining of complex features on material like beryllium. Now, I've been saying beryllium a lot, and the reason I'm highlighting it is because it has incredibly unique properties. First off, in terms of weight, which, as we all know, is the grand prize in terms of keeping costs low. In terms of weight, beryllium is the go-to material. The problem is how expensive beryllium is, and that's the limiting factor. But it's roughly 25 to 30% lighter than aluminum, depending on the grades of aluminum you're comparing it to and the grades of beryllium you're comparing. My favorite aspect of beryllium is that it has an extremely low coefficient of thermal expansion. So I have a few of the figures here. If you look at aluminum, it is 13.1 microinches per degree Fahrenheit as a coefficient of thermal expansion. So 13.1. Stainless steel is a little bit better with 9 microinches per degree Fahrenheit. But beryllium is 6.7 microinches per degree Fahrenheit. So it really can hold all the tolerances and all the features, no matter what temperature changes it's seeing, whether it's in a nuclear fusion reactor that we've supplied, where the inside of that torus can reach 8 times hotter than the sun, or it can be in deep space in NASA's James Webb Telescope, also a telescope that we provided parts for, that's obviously reaching extremely low temperatures. Most of those programs are relying on optics, so metal optics and beryllium optics, to bring back images or to target certain areas, especially if we're talking about strategic systems. Those are all using metal optics, and beryllium is perfect to make sure that if I'm trying to tilt the mirror a few arc seconds one direction, it's actually going to move precisely the distance that I want it to move. So that's the way we achieve mission success for one of the videos that I just mentioned here. But there are many others. If we think of UAVs, like the Global Hawk program, or the new F-35, all have targeting pods that require extreme precision and the cooperation and coordination across a huge supply base that is rarely seen when you're just looking at the Lockheed Martin logo or the Raytheon logo. The last thing I want to say about beryllium, other than it's very light, it has a low coefficient of thermal expansion, is it is not very dense. It's 30% less dense than aluminum, and that means that, again, it helps us in terms of weight, but it also has very unique properties when it comes to medical devices. So one thing that is very unique about beryllium, having only 4 electrons and being very, very light, having only 2 electrons close to the nucleus, X-rays do not get absorbed by the beryllium material. So one of the biggest programs that we're on in the medical device industry is creating beryllium windows for all the X-rays for Philips and Siemens. Whenever you're at the doctor's office or the dentist's office, you can expect that there's beryllium guiding the window inside of the X-ray machine. So the vast amount of applications in this material makes it extremely interesting and makes it fun as a production engineer or even an aerospace engineer to know that there's so much applicability in the types of designs that you're creating on this material that could be in that could be used in a lot of other industries. I've already named energy and medical devices. So that's what gets us excited. That's what gets us out of bed every day. And the next thing I want to tell you about is, even though the end product is extremely exciting and we're very proud of it, the day-to-day is extremely exciting as well. So some of the things that we can expect when we're walking in day out in our factory is that we are dealing with extremely complex problems, not only from a design standpoint and a customer relationship standpoint, but also, as I said before, from process flow standpoint. So what we've developed at our company, for example, we have something we call gauge analytics. What gauge analytics does for us is it takes all the complex planning of all the different part numbers that we are processing through our shop and schedules it in a customized scheduling software across all our labor resources and all our machine resources and our inspection resources. And so we do a simulation of how we're going to be managing all this product through our shop. Sometimes the simulation is going to give us answers that we don't like, that, hey, the simulation is telling us we're going to be 3 months late on this if we don't change something. It'll never give us a perfect answer. So we then have to use that data to coordinate with our engineers on how we're going to change our planning. We need to coordinate with our suppliers, coordinate with our customers, with Raytheon and Boeing and the like. And all of that coordination is an incredibly strong skill set to have beyond your technical skill set as an engineer. And you really get exposure to that as you get to use systems like the one I just described. So if you can imagine, we have a simulation software that's showing us how we're supposed to run the shop. It's going to tell us all the different reasons why we can't achieve the goal we intend. We then have to make assumptions and change things around, negotiate with different people. And then we have to track actuals. So then we also have proprietary software that monitors our machines, what different status they're in, if there's an error, if the machinist needs some help, if a program needs to be tweaked, etc. So we are constantly looking at our simulation. We're looking at the machine monitoring data. And then finally, with our customers and internally, once we ship a product, we look at our actuals. Now, how do we process improve next time around? What you will soon learn to find, especially if you're working in the larger OEMs, the cost pressure is tremendous. And year over year, all of these programs are looking for process improvement. And that process improvement ultimately comes down to companies like LA Gauge and what we can figure out on the floor in cutting the material 30% faster, 10% faster. And so when we think about our company, we don't think of ourselves as just a hardware company or a machining company. Internally, we also think of ourselves as a software company. And that means we're able to customize software, use it to our advantage, and also use it to scale up our operations so we can get bigger, more prosperous, and into more interesting projects. So that's also what's very interesting about being in this industry, being able to work in this kind of technical environment, being able to work on technical projects, and to know that end result, as Bill stated in the previous presentation, the end result is are the most interesting projects on the face of the planet and beyond. So with that, I want to move on to just a couple thoughts, more closing thoughts of how to think about getting into this industry. Whether you're working at a supplier like LA Gauge, we are hiring. We're always looking for smart people who are willing to learn the trade. You can look us up at lagauge.com, and you can also talk to me during the panel events. But I just want to close with a few closing thoughts in general about getting into your career in your 20s, especially as an engineer. There are two pieces of advice that I think at some point I was given, but maybe didn't take as seriously as I should have. But I'd like to relay those two pieces of advice to you. The first is having patience. Whether the beauty of working in some large companies and small companies in this industry is you're going to get a lot of exposure to a lot of things. And whether you know exactly what you want to do or have no clue what you want to do, I think the approach is the same, which is take on whatever is given to you, take on the stuff that you don't want to do. There is overhead and there are tasks in every job that you don't want to do. You can't escape it. And so I would take that as you leave college and go into your first few jobs, take those as learning opportunities and know that right now you are trying to get a lay of the land. You're trying to understand all the different aspects of how a business runs and how a project is completed on time with good quality. Then you're going to start rounding out all of the experiences you've had as you move on 5, 10 years, 15 years later in your experience. So I would just highly recommend having patience and taking all the tasks that are given to you in good stead, because remember that whatever strengths you have, any strength a person has also has an inherent weakness on it. And the vice versa is true. Any weakness you feel you have, there is a strength associated with it as well. So you can't rely on your strengths. You have to know that that is also bringing out some weaknesses, and you probably want to test yourself on those weaknesses as well. And taking the tasks from more experienced people in the industry is a really great way to do it. So I just think that's an incredibly important mindset as you go into your first few jobs. The last piece of advice, which is related but slightly different, is it still also goes to mindset. And that is the team, company, and customer mindset before oneself is always going to pay off in the long run. Whether that company has its own issues or cultural issues, you will figure that out over time and you will make the right decision for yourself. But if you are always thinking about company, customer, program first, everyone will notice whether they say it or not, and you will move ahead in the long term. And from my vantage point, when we see that in our employees, they might not know that we see that, but we do, and they're rewarded efficiently and effectively. So with that, I am more than happy to give more perspective or answer more questions during the panel. I hope this was a useful perspective, a little different from the other presentations, and thank you very much for having me.
Yeah, thank you, Mr. Bawa. This is amazing. That's exactly what the young people would need, and very. Just that hopefully you're okay because the session is being recorded. So if you don't feel comfortable, let me know, we can remove it. Otherwise, we'll post it on our website so more people can watch it. It's okay. If not, we can remove it. No problem.
Yeah, we might have to remove the video.
I know. Yeah, no problem.
Yeah.
I'll check with you.
Yeah.
Yeah.
But I hope you guys enjoyed it.
Yeah. Oh, greatly. That's
yes,
amazing.
We can't post that online.
Of course, understand. Okay, so now we are moving to the panel, career panel. This panel is to give advice to the student, and student can ask questions, and that will be followed by the breakout session with each of the individual speaker panels for more deeper conversation separately, privately. So okay, so now we'll bring up the panelists. Of course, Jyot, you are one of them, and then there's we have Phil. Let me put it in. And Jennifer, yes, Jennifer, thank you. Yeah, if you turn on your video, then we will be able to spotlight you. Yes. Oh yes, thank you, Bill. Yeah, that's right. Bill, can you turn on? If you don't want to turn your face, you can kind of do in the virtual background and just cover your camera or something.
No, there I am. That's okay.
Okay, thank you, Bill.
You guys need to know how old I am.
No, you're young.
Okay.
Okay, Dr. Melamed, and I think with Bill and Dr. Claire Leon. Let's see, Professor here. Okay, Professor Leon, can you kind of turn on your camera so we can add you to the spotlight? Okay.
Hello.
Yeah. Oh, thank you. Hello, nice to see you. Here. Thank you so much for joining us. Okay, so do we miss someone? I think we, Bill is here. So let's see. So Bill, yeah, Mr. Cook is not here. Sina, who is Sina? Let's see. Sina, where is Sina? Sina, could you turn on your camera so we can add you to the spotlight?
Yeah.
Okay, if you don't, if you don't want to show your face, you can cover it with
that's
the camera.
okay.
That's okay.
Can you guys see me?
Yes, I'm going to add to the spotlight. Yes, wonderful. Yeah, we have wonderful panel here. Just double check if Mr. Cook is here. Yeah, he's in Texas, so he might be a little bit. All right, so I think I don't see him right here, but whenever he joins, we'll add him. Yeah, he's an engineer, a contractor with Lockheed Martin. So I was trying to get him to share with his experience. Okay, so thank you very much for everyone. We have a great panel today. So we'll have chance for you to ask your question. Those panels very professional experience and aim to help you. So you can learn that from them. So I think because some of the speaker we already have the introduction, so people kind of more familiar. So I think Dr. Claire Leon and Attorney Jennifer Perdigal has not been speaking. So let's start with them for the introduction. I'll start something very quickly, so you're welcome to just self-introduce it, and then we'll go turn around and just quickly say something. So Dr. Claire Leon started her career at Hughes Space Communication Group in 1979. She gained experience across the company through stations and increasing responsibility in system engineering and program management. And she was promoted to Vice President of Navigation and Communication System within Boeing in 2008, responsible for the Air Force satellite programs as well as a number of classified programs. She transitioned to Vice President of National Programs later in 2008, where she led the program turnaround for a critical ACAT-1 program on the customer contractor responsibility watch list. That became a high performance program delivered outstanding operational capability. She also transitioned the National Space and Communication Program from a cost plus to fixed price in response to customer affordability concerns. She retired from Boeing in 2013 as Vice President of National Programs. Dr. Leon became a member of the Senior Executive Service in the Air Force as the Director of the Launch Enterprise Directorate at the LA Air Force Base, California. In 2014, she was responsible for buying and launching rockets for the DoD, as well as leading the transition to the next generation of the launch systems. She is currently running the graduate program in space system engineering in Loyola Marymount University, LMU, as well as consulting for SAIC and Inside Out Learning. LMU was the school university that Bill already mentioned. He gave a presentation of MMRTG with a student, Dr. Leon there. And Dr. Leon's education background includes PhD, Executive Management, Director School of Business, CGU, Claremont, California, 2010, Master of Business Administration, UCLA, Los Angeles, California, 1995, Masters of Management, University of Redlands, California, 1986, Bachelor's in Mechanical Engineering, George Washington University, Washington, D.C., 1979. She's consulting service to perform management consulting for Inside Out Learning and SAIC and possibly additional technical management companies. Tasks including executive presentation, support, coaching, strategic planning, feedback on management approach for resolving challenging problems, as well as supporting two independent program review teams. And they are trying to establish a new AIAA chapter there. So folks here can interact with her, for getting some advice and information. And the attorney Jennifer, just quickly go through, and you're welcome to introduce yourself. Attorney Jennifer Perrigal is a partner and co-chair of Trestler's Transportation Practice Group. Her practice includes insurance coverage and the defense, as well as advisory matters. Jennifer's insurance coverage experience includes insurance coverage analysis and the insurance litigation involving various aviation-related policies. Her defense litigation experience involves a wide range of matters, including the defense of wrongful death, personal injury, and property damage claims arising out of premises, aviation accidents, airport operations, and the product's liability. Jennifer further provides counseling in connection with FAR compliance, risk management, and aviation contracts. Jennifer has training and experience with employment law matters, including FEHA claims and the wage and hour matters. She is a licensed pilot. We want to inspire everyone, and enjoys helping young women pursue aviation-related career. That's perfect. She earned her JD from Pepperdine University School of Law, and currently works at Trestler Los Angeles office. So for her work, not only she's involved with aerospace, she actually has a customer and major aerospace company, but herself has a great passion for aviation, aerospace, and herself is a model, also the Dr. Leon model for women professional, pursue for professional career. So that's so I think that's so maybe we should do this. If any question, audience, please just raise a hand. So I think the first question, and when you start, and make sure you also quickly introduce yourself just briefly and say whatever you like. But the first question is very obvious, is like today UNLV, they are severely impacted by COVID-19 pandemic. And you see, Aerospace Corporation obviously has some kind of responding strategy on this, so they keep doing very well. And Mr. Bawa, you show the picture of your factory, is any kind of COVID-19 kind of impact, and your company is hiring, and how to ensure the employees safe, and country. So kind of COVID-19 impact on aerospace, and for your school, your company, or or flying, how does that affect? Is any suggestion to the students and the attendees? So maybe we should let people just go first. So how about Dr. Leon? Would you like to start?
Sure. So I think, COVID's pretty profoundly affected the entire world, right? So I think the first thing is to recognize that this is an unprecedented time, and you'll remember, people who have lived through this or are old enough to remember will remember it for the rest of their lives. It's just a fundamental challenge for the world. between family members that have become ill or have lost their lives, or friends, or the lockdowns. So with respect to Loyola Marymount, you know, obviously a very profound change. I remember giving a lecture right before spring break and asking this group of freshmen, you know, wow, so who's traveling over spring break? And every hand, I mean, almost every hand shot up. And I never saw them in person again. And I, you know, haven't to this day. And so, so over the course of spring break, the other faculty members and I ended up having to flip our classrooms from, you know, synchronous in person into asynchronous. And my class was dispersed around the country. There was one student from Siberia who ended up quarantining for a couple of weeks. We kept trying to reach him and couldn't. And finally, he did reach back to say that he had been in, you know, in lockdown and, you know, couldn't keep up with anything. And honestly, we've not heard from him. But we had students in Jakarta, Monaco, Rio. It was sort of fun from that standpoint. And we kind of coped by having office hours, but all of the classes went asynchronous. So we videoed the classes and then posted them. We still had students do group projects, so that was good. But we also had office hours, and it just gave us an opportunity to keep in touch with students, but and kind of take the pressure off. So, you know, I know I've also been doing some consulting for the Air Force, and so the, you know, the rules for entering buildings is, you know, wearing masks, minimum number of people in conference rooms. So people are learning how to survive, but. So anyway, again, I think it is important to acknowledge it is a, you know, a monumental, let's hope, once in a lifetime event that we're all learning to cope with. And sometimes knowing that something's that big can help bring the stress down. But I do think it has created tremendous amount of stress with students of all ages from kindergarten through college. But I think it's important to have some optimism that we will get through this. This is going to be behind us, and it's, you know, every week that passes, it feels like it's getting a little lighter and a little more manageable.
Yeah, that's one of, yeah, you're very good at the psychological impact. So any words, you know, few words advice for student graduating, looking for a job during this, you know, tough pandemic time?
I don't really think it's any different than any other time. Use your network. Don't count on just applying to jobs online. You know, figure out who knows who and see if you can get, you know, your name in. All companies, all the big aerospace companies at least have an online system where you have to apply online, even if you have a connection inside. But what I try to do to help people is, and sometimes I've held, you know, even Zoom meetings where we pull up companies' websites and look for different types of jobs. So if your degree is mechanical engineering, don't limit yourself to just applying to jobs in mechanical engineering. Look at things that are related, like, and again, if you're, I'm kind of a space geek, but, you know, attitude control, test is my favorite place for students to get started working with hardware. That's kind of how I learned, I don't know, that's where I got my good start, was I called my cable dragging days. But so apply to lots of different types of jobs, but also, so again, what I try to do is help students find other job categories than just their strict name of degree. You know, systems engineering, test engineering, production management, process control, material processes, DPA, you know, again, depending on what your degree is. But, you know, go broad, but then also try to find some people inside the company to say, hey, do you know anybody who can look out for my resume? The other thing that's important is read the job description and then make sure your resume has every key word. So if it's an attitude control job, your resume needs to say attitude control. Or if you think you might want to do test, then make sure test is in the job. You know, like, I'd love to have an opportunity to work in test. Make sure that the keywords in your resume match the keywords in the job description, which means you need to tune your resume to every job you apply to.
Excellent. Actually, yeah, very good. Actually, I'm sorry, Sina actually forgot to introduce you, but let's go with Jennifer, and next to you will introduce you, Sina. Sorry for that. So,
yeah, no problem.
Yeah,
no problem.
Okay. So Jennifer, yeah, you know, you're in the attorney, kind of different, but you are pursuing also kind of aviation, aerospace passion, and your work is highly related to aerospace as well. And you know a lot of inside thing for aerospace. So could you? I know your office has been impacted by the COVID-19. So can you tell us about how this industry cope with COVID, and also for example for you, how does that affect you? Being as a pilot, how does that prevent you from enjoy the fun of aviation? And can share with us the fun of aviation, those things for people, especially people want to. But there are quite still many students that want to become pilot, and also they are building airplanes.
Well, first on the professional side, and I think Dr. Leon, she hit on this to continue networking. And I think that's such an important part of getting jobs and getting into the career and exactly where you want to be. And I think that's been the challenge of COVID, partially, of how do we network in this field. A lot of the conferences I've always attended, there's a air law symposium, and they're all aviation related things, and a lot of them are just all day lectures, and you tune in, you tune out, but there's no networking, there's no back and forth. But then there's another organization, the International Aviation Women's Association, and that one, they actually did a great job. They did breakout sessions where they would kind of randomly assign industry people with attorneys and consultants. And so you got a chance to meet different people and actually communicate with them. And the International Aviation Women's Association, it's an international organization. So it's a little odd because for us, it was like, I think it was 5 a.m. in the morning, and other people, it was normal time, because I think it was technically in London this year or Singapore. I can't quite remember. So that's where they did the baseline. But it was a great experience because, normally we see each other at the annual conference, but we couldn't do that this year. And we still got the chance to communicate directly with people, meet new people, and network. So when you are looking at networking opportunities, I would look for the ones that do have a social component to it, or a networking component, where you actually get a chance to sit there and talk one-on-one, or even in a small group, about 4 to 5 people. And that gives you a good way to meet people and increase your network, rather than just going to lecture sessions where you don't actually, people might not even know you came. Your name might pop up on the side, but otherwise you might learn more about other people, but you haven't established a connection there. So I think in COVID, I think that's been kind of my major challenge, is finding those activities where I could keep in touch with my clients, continue business development, and keep on going. On the flying aspect, I have to say it's been a great time for general aviation, because I think initially nobody knew what was going on, and the skies were pretty much open. So I think it started to fill up again, but from that standpoint, if you already had your license and it was all, it was a good way to kind of be able to do something and get out of the house without becoming overly exposed. So.
Yeah, this is fascinating, and I can tell you we have a couple women or young lady professionals and or students. They are really inspired. They want to become pilots, and they study aerospace engineering. Really very. So there's a very good advice. For you to during the pandemic. Okay, so we'll have more questions come back to you and Dr. Leon. So the next is, because Sina was also not speaking, so let's introduce him. So Mr. Sina Abertorabi is an experienced engineer, electrical engineer, communications engineering, and astronautical engineer with demonstrate 12 years of industry. His history of working, teaching, and learning in the interdisciplinary areas of electrical engineering, communication systems, telecommunications, and aerospace engineering. Is skilled in astronautics, spacecraft systems, deep space communication coding, digital space communications, algebraic coding, satellite communication, wireless communication, mobile communication, radar signal processing. RF systems, antenna, and microwave engineering. So these are all the hot topics. Sina has been part-time teaching faculty at CSULB. In case you don't know, it's Northridge, Cal State, Northridge, Department of Electrical Engineering. Okay, so Sina, so how do you think? Now you're working in a different area, but can you tell us more your experience and how you give advice to students, young people, cope with the COVID-19 and efficiently and overcome the difficulties to find possible opportunities or advance their careers, and your experience now.
Yeah, hi everyone. Thanks for the explanation. So yeah, basically pandemic took a really big toll on everyone, especially on academia. So a lot of the students are miserable, going back and forth between virtual meetings with their professors, advisors. Obviously, it's pretty hard. And in fact, I was personally, I was involved in a flight training school myself, and ever since the pandemic started, I wasn't able to finish my flight training, unfortunately. I'm sure Jennifer can probably talk about this issue. Have you heard about the issue, Jennifer? Like, I think most of the flight training schools are ceased as of now.
No, actually, I don't. Where are you located?
Well, that was back in Glendale in Los Angeles. Now I'm in the Bay Area.
Oh, okay. I know all our local. I fly out of Hawthorne Airport. All the Torrance and Hawthorne Airport schools are all back open.
Oh, they're back open. Okay.
And I believe Long Beach as well. And they've actually been open since quite some time.
Okay, so yeah, because anyway, I stopped going back to the flight training school. But for students, my advice would be pretty much like everyone else has mentioned. I would strongly urge the students to, enhance their network of people, their circle of friends through socializing events, events like AIAA or there are tons of different events nowadays online. But more interestingly, I think from what I know from so many industry leaders, these days, it's better to have like an internal reference through your network or connections. So if you get an internal reference, your odds of resume being picked up and selected is drastically higher than just like, applying electronically. Because when you apply electronically, as Claire mentioned, it's somehow you have to kind of pick up a very corrected version of your resume, and it's personally I wouldn't suggest to I know Claire said that I wouldn't suggest to update your, maybe you can update your resume a little bit, but I wouldn't suggest to change your let's say your areas of expertise, because every job position or every job category has its own descriptions, right? So I understand that, but to me that's going to be a little bit, it's like a hit or miss. But I think what Claire meant was I think she just meant the keywords. The keywords should be fine, and she's absolutely correct, because when you pick up the correct keywords, this because these companies, they're the way they select like good resumes is based on machine learning systems. So they have this computer screening. So technically, a human eye is not going to get your resume checked up. So the best thing to go is, as Claire said, is to update your resume, but try to be more, try to have like some dignity and honesty. You don't want to put on like so many areas of expertise, that you have you don't have knowledge in, because in your phone interview or your on-site interview, you might be asked, like, for example, what have you been doing as a wireless communication engineer, like for this specific company? So you have to explain yourself pretty effectively. But going back to the LinkedIn, I think LinkedIn is the best network in terms of socializing and getting connected to industry leaders and especially aerospace engineers. And it's best to maybe you can send, if you find someone, let's say working at JPL, maybe it's best to introduce yourself. Don't be shy. You can always send email or messages to people on LinkedIn, and just try to introduce yourself. And as time goes by, you can get the conversation going, and maybe you can ask for, I don't know, like, because of the COVID restrictions, I don't know if people really feel right to go out these days, but you can always even ask, like, I would be more interested, to, if you have some time, to go out with you sometimes, maybe we can get a coffee, or just maybe you can also mention about your own interests, your basically your overlapping interests, with that person. If you're interested in, let's say, in radar signal processing or satellite communications, and you've read this person's resume or like research paper, or you've met him in a conference, and you can always show your interest. Hey, I'm more interested in this part of your paper. I was wondering, like, how did you handle this, conclusion, or this part of your analytical paper? So it's always good to, open up the related discussions. You don't want to show yourself like, sometimes even needy, or like you don't want to be like kind of aggressive. Hey, like, I'm looking for a job, things like that. So I know, like, LinkedIn has been very successful for a lot of my friends. They got their industry or company jobs through LinkedIn, especially internal references. And of course, there's so many other electronic online infrastructure, like ZipRecruiters, or you name it, like Indeed or Glassdoor, USA Jobs. I don't necessarily recommend that, to you guys, because it's going to be a waste of time. Because I'm sure, as a lot of a lot of these, posted jobs, if you just do a Google search, a lot of these posted jobs, they don't really exist. Like, like, what I mean by they don't really exist, because they already have someone else's in mind. Someone is already ready for the position. They interviewed him, but they have to basically publicize it, because of the labor regulations. So a lot of these positions are already taken. So you might just want to kind of waste your time. I'm not saying it's impossible, but the odds of someone finding a job through just like online application or submission, and just say, hey, I'll cross my finger in the name of Jesus, this is going to be almost like nearly impossible. But it's it's not quite impossible. Maybe you have to apply like 1,000 positions every day. And imagine if you want to change your resume, that's going to be like a burden. It's going to be really hard. If you have to update your resume, change the keyword, it's going to take a lot of time. So again, it's always best to enhance your connection and your network, and try to socialize with people.
Yeah, fantastic. That's very good. Really appreciate it. So we'll come back. So then we go back to the order of today's presentation. So Phil, sorry, disturb you. Could you make some comment, for example, like your company or something, how they handle this, and how you're a long time with Northrop Grumman, so is the hiring, the COVID, how to keep employees safe, and any advice for the young people, for efficiently looking jobs through the difficult time.
You're talking to me.
Have some limited advice.
Mr. Barnes.
Bill.
We'll take a Bill. It will come back to you. Sorry. Yeah.
Yeah, Bill, we sound alike. Phil and Bill is very close together.
Right. We look alike too, except I got a little more hair than you do.
Okay. There was a time in the past when I had some hair like you. Okay. I do have a little bit of advice for the students. If I recall, several times throughout my career, and I have just recently retired from Northrop Grumman after 40 years. But I remember several times when I received an assignment, I didn't think I could do it. And what I would advise the students to do is to take a positive approach and think that you might be able to actually break through it and do it. So don't give any indication to your boss that you doubt your ability to carry out that successfully the assignment. Give yourself, and my specific example was electric motors and a generator operation. That was a task that was given to me 30 years ago, and I didn't think that I would be able to do that, and ultimately became a key part of my presentation that you saw today. Another thing was that the company, Northrop Grumman, offered a master's and after-hours master's degree program to get a master's degree in aerospace engineering, and that's the best thing that I ever did for my career there. And it ultimately led to the preparing of writing a lot of technical papers and the independent research that I showed today. In fact, my presentation today was entirely research done at home. And so in that case, when you present a technical paper, you do not associate yourself with your employer. You associate yourself with some small company or whatever. I have written a mix of papers in affiliation with Northrop Grumman and other papers that were not related to my work. Collaboration, I did have collaborated and provided some mentorship to engineering teams doing their capstone projects. And in many cases, the results of that collaboration fed into my technical papers. So it was a bidirectional learning between mentor and students.
Okay, excellent, very good. I really appreciate, Phil. This is fantastic. Yeah, sorry to mention your other affiliation. You know, I do understand, but this is for the career panel. So during your talk, we didn't emphasize it. Understand. So appreciate it. So the next will be Dr. Melamed. How do you think? Aerospace is doing wonderfully. I think the aerospace, as you said, they're hiring. And how about the COVID-19? So is there any way to efficiently apply jobs through aerospace and kind of, or the prevention, precaution for working safely, with aerospace corporation, those things?
Yeah, we've been affected significantly by COVID. I haven't been to my office in a year now. Been working from home on my computer. Those that needs to be hands-on with equipment or other things, to have permissions to come to work in person, but it has to be permitted with all of the precautions and everything else, and it's much more complicated. So we are currently in hybrid mode where most people telework, and it's quite successful with a large variety of collaboration tools like the one we are doing now. That's pretty much the kind of environment that we function, most of the people at aerospace. There are talks about going back to the office. I think it's probably many months away, waiting to see how the vaccines are going to affect the risks. At some point, it will have to come back. There were surveys that were circled around, and sounds like most people kind of like the hybrid mode where they combine teleworking with some in-person time at the office. People do need social interaction. They need to talk to people in person. It sounds like that this is something which is needed. So it looks like at some point when the situation will allow, people will start to come back to the office, at least for part of the time. And for me, definitely that's going to be the preference, to kind of have a hybrid mode of operation where I will work from home when possible and go to the office, part of the time. Let me, if I can share the screen one more time here, Ken.
So you should be able to do it.
Okay, so let me go to screen 2 here and share this. So can you see my screen?
No.
No, not yet. Yes, no.
I can see it now.
Okay.
Yeah, we can see it now.
Okay. Can you see like the aerospace career page?
It says take your place in a space.
Okay, good. So what I'm going to describe here essentially is applicable to every company, really. And I found it quite useful for some of the people who are looking for jobs. So every company will have a career page, on its website. I kind of looked at Aerojet Rocketdyne. They have one here similar to ours. I didn't explore it really, but if you're interested in the kind of thing that they do, JPL or any other, the other companies that were mentioned here, every company will have a similar page. And what I typically suggest to people who are interested is go down here and see what's available in those categories. For the aerospace, as I mentioned, there are several categories here. And you can pick some of those subcategories to focus on If you're an experienced professional, you might pick that. If you're students or recent graduates, which sounds most of you are, that are looking for a job, you can go here and it will tell you what are the possibilities in terms of summer interns and so on and so forth. And at some point here, there's going to be explore student and recent graduate jobs. These are open requisitions, which are up to date. They change probably several times a week or every week or two, with new opened and others closed. And my suggestion is to go and visit the career page for the company you are interested in and just see if any of these might appeal to you in terms of area of interest, and just click on it and see what they are asking. And you might even be able to target your resume to the kind of functions they are looking for, right? They're looking for certain things, and some of those keywords you can insert into your resume to increase the chance they'll be picked up by, the recruiters. So I found that this was useful for some of the people who are looking for jobs. It's good to have a targeted resume. It's difficult to change it from job to job, but every company you can create a targeted resume for the company and add as many keywords that will increase the likelihood of a good fit with a job that you're seeking. I think if you go to the career page and look at experience, they have a lot more openings. Let's see. I think you can look at the different culture types of information, benefits, and so on and so forth, and see if that's a place you would like to work for. And just explore all of the open requisitions that exist at any point in time and try to target your resume. There is 245 results right now that are open. Maybe they are not a good fit for you in terms of your experience, but there were a couple of dozen that were looking for recent graduates. I think that's an opportunity to try to target it. And again, other companies will have their own environments. Here's Rocketdyne. They have different areas here, students, and so on and so forth. So you can explore these. I think it's very helpful to do that. That's my advice to prospective students.
Excellent. Yeah, that's fantastic. That's exactly what student need to be tailor their resume with the keywords for the dream job they want and for a specific company culture. Okay, so so Bill, how do you think? Any advice you can give? You are very experienced in these things.
Can you get the screen back? I'm not showing. Yep, there I am. Okay. Yeah, short and sweet at Rocketdyne, and I talked to a few people since the pandemic has hit. All the engineers went home, just like Dr. Melamed said. If you can work from home, you're asked to go home. But they kept the shop open, and mainly because there were NASA contracts involved, and they got a waiver for the restrictions. But also, if you've been in a big shop like Jyot may have been in, social distancing is already done there. There's big CNC machines that are stationed in various places for a manufacturing process are absolutely more than 6 feet apart. And so all you need to do to get it to keep going is to have your folks wear masks. I believe they wore masks during the operations, but they were able to with a minimum of impact. So I have that, and I also have a question for Dr. Leon, and maybe this is worth sharing with students. Do you think that the pandemic has turned an A+ student into an A- or B+ student? The malaise that is described as the effect of not being able to do anything, or is that classified information? Are you allowed to say that? I want a quantitative answer. A- goes to B+, et cetera, okay? Shoot, yeah. I yield the rest of my time to Dr. Leon.
Well, interesting question, but and I'm sure Sina would say the same thing. It really depends on the students. Some students, became very depressed and frustrated and really struggled. And so one of the things LMU did was they allowed students to transition and as many classes as they wanted to credit, no credit, so that particularly that first semester and then probably the second semester wouldn't kill their GPA. Some students thrive because they're kind of hermits anyway, and they love the isolation time. And so there is obviously not one answer. And then you have students who just figure it out and use the resources. So I think, a lot of faculty members are very open to, having virtual office hours where students can just drop in, or doing one-on-one sessions. So everybody's different, but online learning is not for everybody. And so some students definitely struggled. And, and even if they got an A in the class, they might have just hated it. And so it was, just very frustrating. So anyway, sorry, I don't have any quantitative numbers, but everybody's learning to manage their way through.
Yeah, I get that from high school students too. I talk to about this. Some of them doesn't even matter. I mean, yeah, keep doing it. I think it depends on how totally integrated they are into the electronic society. If you're just using it just because, or if you're really involved with it every day, and it becomes second nature to you. And that's the way kids that are 7 years old are still doing stuff on their computers, and it's not phasing them much. Some.
Again, a lot of middle school, high schoolers are having a lot of trouble. And I know that more from colleagues with kids than from my own kids. I've got grandkids and grown kids and nothing in between. But
if I may add a piece of information actually from my wife. She's teaching at the local community college, and she insists on meeting one-on-one with a lot of the students. And she says that sometimes this actually makes the difference between the student staying enrolled versus dropping out. It's really important to have a personal connection with the students and give the student an hour of your time every once in a while to encourage the student to keep being enrolled to class. Otherwise, you lose them. Not every student is strong enough to have the discipline to overcome those difficulties on their own. They have life situations and stuff like that, and the pandemic just complicates things on them. You got to give them some sort of a personal treatment, which is easier in person, but she's doing it live, and she insists on seeing the student and talking to the student and encouraging them. That's something that seems to be working on some of the students.
Yes, Dr. Melamed is correct, and that's exactly we designed this breakout session later on, so you can have one-on-one, one-to-one relation, or one-to-few if you like. And then the other thing is, before we go with Mr. Jyot Bawa, was if you look at our dream team today, the dream panel, if you look at this, it's a very complete set of the aerospace. For example, Dr. Claire Leon with Boeing, obviously space program directorate leader. And you have Phil is an aircraft designer, and you're looking for the future electric aircraft. And Dr. Melamed is for this, this oil mechanics planetary defense, which is very important hot topic. And Sina, you were working on the communication, DSN, electronic avionics, and look at Bill, rocket engine, and the MMRTG, and Jennifer, you're working on the legal issue, with aerospace, important, protected.
I'm here when things go bad. Hopefully that doesn't happen, but that's why.
No, don't worry. You are. We have all lucky star here. Don't worry. And Mr. Bawa is the president of the material company, so we have almost everything. Today is really it's a dream team. So we should, everyone should take a great opportunity to ask questions one-on-one, those things. So, Mr. Bawa, how do you think? You are the employer, you're the president. How to give suggestions for new people for working in your company, or in general, how to find opportunity, or how to keep it safe working in your company or other manufacturing company. And the one thing that's why I've been talking to Roslyn is people are crazy about the 3D printing, but your company is doing kind of and I heard there's some kind of new development. You can let the student know it's still very exciting. Otherwise, students are always thinking about 3D printing, but there are certain things you just cannot do 3D printing, So they need to go to your company, which is actually very important. They didn't realize. Yeah, go ahead.
Oh, yeah. I went from having nothing else to add, and then you said 3D printing, and now I have to limit myself.
Just a comment.
All right. No, because, well, so on the first part of hiring and recruiting on both sides of the table right now, everyone said the main points. I think everyone needs to understand that applying through a website is just as ineffective now as it was 10 years ago. We spend 3 seconds on resumes. We do look at keywords. We can tell when a keyword doesn't match the experience and it's a load. No one has 4 pages worth of experience. I still don't have nearly 4 pages. I probably only have half a page of experience now, even. So that point, I want to +1 that. The second point on LinkedIn is also valid. I think the only thing I want to add to those channels of getting a job is 2 things. One is a channel and one a mindset. The first is Bill brought up writing papers, and Phil said this earlier. That is going to those conferences, getting closer with your professors and your graduate student instructors is key. That's how I got my first job out of Berkeley, was working on a startup with my professor and GSI. I think that is an excellent way to get to know people, especially most folks who are in this Zoom call are at large schools, and not every professor is as generous as Dr. Nahum's wife is. So if you're able to find that one-on-one time, it is an added advantage. The second thing is a mindset, just kind of a reminder, because I know this panel is more talking about large projects, large companies, and this is individualistic, but remind yourself of the position you're in, the flexibility you're in terms of your age, and what's your risk tolerance. Keep in mind that you can take many people, I can't say this for everybody, depending on their financial situation, but many people can take bigger risks at this stage of their life, and it's okay to mess up on choosing the first job. You could be wrong, and you'll be just fine. And I think sometimes we have to remember that as we look at all the different options. You can't know everything about the position and the company you're getting into from the outside. And you might be surprised, and when you're in there and it's something you didn't expect, don't be discouraged. You're allowed to make mistakes and find that stuff out in the first go around. And I think if you can't really find that right fit, I don't know if I'm allowed to say this, but think about grad school. Maybe this is the time to continue doing the education and punting on the career search when things open up a little bit more and you feel a little bit more comfortable making those personal relationships, or you need more time for those relationships. So be creative in thinking about next steps, but don't put too much pressure on yourself. You're going to be just fine. In terms of internally at our company, I'm going to reference Bill again because he nailed it and has nothing else to say. Our machines are far apart. We work with beryllium. I didn't mention that's a toxic material. So our environmental controls are extremely robust, just to keep the air pure and the temperature controlled. So as long as people are socially distant, we're doing just fine. And yeah, our shop is open. I've been going to work every day. We're kind of that essential workforce. If you notice, many of the large companies, the shop is still open, so we're still open. It's been very difficult getting everyone up to speed on virtual communication. You just saw my issues just a few minutes ago. But I guess outside looking in at applying to a small company like us, number one, if we're open, you can be confident that we're taking care of our employees, and that's generally true. And two, if there's some hiccups in meeting in person or virtually during the interview process, be flexible, be forgiving. I'm old and I don't know how any of this works. And I think I'm speaking for a lot of people in my position. So I think that's all I have to say. I really do think the biggest points were already said.
Excellent, thank you, Mr. Bawa. This is very crucial, ultra important from your view. So, I think the next question, everybody, if any question, you're welcome to raise, but we have kind of limited time before we move into the.
Ken, may I add a point
yeah, sure.
to Bawa? So I was going to actually, I'm sure almost every university now they're offering career fair at the beginning of their either fall or spring semester. So career fairs are another gateway to apply for jobs, like in person. But of course now everything is through Zoom meeting and online. But hopefully when the pandemic is over, this is probably one of the best and most effective, because usually what happens in career fair, you have a chance to to talk with the company, team lead or the recruiters in person. Usually if they like you, they're going to mark your resume, and then you can take it from there. You're going to get a call in a week or so. So
very good, Sina. So that's now the next is kind of important, but probably will be focused on more the people have interest in the expertise on this. So yeah, of course, these days the kind of diversity is an important subject, and we know Dr. Leon and Jennifer as great leaders in the women professional thing, and the bill has been promoting trying to get as many girls, women into STEM career, and all the rest, these are also very supportive for minorities. So can you kind of comment about how to encourage, if your student is a minority, and how to encourage them to move on and then overcome the challenges. Dr. Leon, can you kind of get some quick comments, encouragement for people, especially in those status?
Well, I think you just kind of have to pay attention and show you care and be available for people who want to talk, but also be observant. So if you see that there's issues, is make yourself available. And I really liked what Nahum said about his wife, about scheduling time. So I think it's taking, it's one, paying attention, tuning into what people need, being available, being empathetic, and being encouraging. And then, another thing as a leader, what I would try to do is look for opportunities and then help steer people. And, there's always human resource constraints. So you can't say, oh, I think this person should get this job, but you can say, I think this person should have the opportunity to interview for this job. And if I have personal experience, then I might say why I think they'd be a good fit. The person has to earn the position themselves. So you can't force a fit that isn't there, but you can help facilitate.
Fantastic, thank you. Dr. Credio has a great experience. He gave a lecture last year, so welcome to ask her more questions in the breakout session. Jennifer, how do you think? Give some.
Well, and I agree. I think there's two things. One, what I try to do, and I would say this is more geared toward women, because I'm in a lot of women's groups in aviation, because as you know, aviation is still, it's still more men than women. So I do try to steer them towards the organizations that provide that extra support. So you're giving them support, but then you're also getting them into an organization where they're meeting people like them. I honestly, I particularly like the International Aviation Women's Association, and it's a global organization. You're meeting people from Airbus in France to, Boeing employees from actually the UK. It's a very global, and it gives, especially if you're from Los Angeles, which obviously is a large city, but you're still getting that international perspective, and you're seeing women across the globe succeed. And it's really, I think it's empowering. And the other thing is, I think sometimes when we get busy and things get stressful and crazy, we forget to say thank you, and people that, hey, you've done a great job. Thank you. And I think people need to hear when they've done well, you need to tell them and you need to reward them for a job well done. And I think that adds to their stress when they think okay, but they're not sure because they've not gotten the positive feedback. So I think I make a concerted effort to always try to say thank you. And even within our firm, when somebody does, like when a second year associate does something like wins a summary judgment motion or settles a case on her own, yeah, I send out an email to our entire aviation practice and say, hey, so-and-so did this. Yeah, join me in congratulating her. And it really changes her attitude and changes their attitudes. And they're appreciative of that. So I think that's the positive reinforcement. I think that's the way to go.
Yeah, Jennifer, Dr. Leon, and actually, if you look at our student branch earlier today, 3 out of 4 branches in LALV section, the chairperson, actually girl, woman. For example, UCLA, you see Alva, she was representing the USC RPL, and Randy, and then you have Cal State Long Beach, you have Diana, and UNLV, you have Sophia. So, of course, they also have co-chair as gentlemen, but I should say it's a very encouraging sign. And actually, a couple of these, they actually want to be pilots. They're actually taking the flight school, those things are fascinating.
And I highly recommend especially if you're in the aviation aerospace industry, I do recommend getting your pilot's license. One, from a job perspective, I'm in a flying club with about 50 members, and I would say about 30 out of 50 are in the aviation aerospace industry. So right there, that's your networking. There's a network right there. And once a month, we get together for maintenance day. Not right now, not for the last year, but normally. So you have this built-in opportunity to network with the Los Angeles aerospace industry. 2, it's a huge confidence builder. All of a sudden realize that, oh, I can fly a plane. And I've noticed the change in, I'm also on the board of the 99s, which is a women's pilot organization. I've noticed the change that people go through, when they first solo and then when they get their license. It's a fundamental change in their confidence level. It's that they can kind of take on the world. So I think it's a phenomenal opportunity, and I highly recommend that as a companion to your aviation aerospace career.
Fantastic, Jennifer. Well, those people know, that contact you or local people. And recently there's a news about I think the pilot Kelly Latimer, says the news about her, the Virgin Orbit, the launch. Okay, great, very, very good point. So this time, Bill, Mr. Kelly, you have been promoting in your talk for the girls. How do you think about encourage minorities and women, girls to go into aerospace, STEM?
Yeah, I do a whole thing about that. I do a presentation. I think Jennifer was listened to that. Let me say a few things. My wife was an elementary school teacher for 25 years, and she would always tell me that you lose girls to math and science by the 4th grade. She saw it happen in front of her eyes many, many times over. They are somehow convinced by their parents or their peers or by somebody that girls can't be doctors, girls can't be engineers, girls can't do things like that. I had a niece of mine who is now 40 years old. When she was 10, I asked her, what do you want to do when you grow up, Mary? She said, a nurse. I said, why don't you want to be a doctor or something like that? She said, girls can't be doctors. This was when she was 10 years old. So I have done things in elementary school. My advice to all of you is start doing something about this, encouragement. Don't wait until high school or college. Get down to the 4th grade. That's where it's happening. My wife was right. Because you can see a young girl in elementary school in the 1st or 2nd grade, the girls are beating the guys like crazy. They're much smarter, much more energetic about schools. But then by the 4th grade, the numbers start to fade. And then by the 6th grade, they're like gone. Maybe that doesn't happen much anymore, but that happened all through my life. So I'm sharing that experience with you guys. And the punchline of my presentation about this is that as a society, we do not recognize women as capable in general of intellectual exceptionalism. I get that term from a paper that was done by a psychologist in New York University, my alma mater. And if you see it, it's an age thing, or it's a timing thing. If you go down to UCLA and you walk through the engineering building on the floor where they show all the graduating schools, you can see that girls in the beginning of the 20th century didn't appear in the pictures, but they gradually appeared, and now it's hopefully 50-50 by 2021 here. And you can tell by the number of Nobel Prizes that are awarded to women versus men. My example to women is Marie Curie, who has 2 Nobel Prizes, one in physics, one in chemistry. And a recent teacher at UCLA got a Nobel Prize for some, I forget what the subject matter was. So the facts dispute the notion that women are incapable of intellectual exceptionalism, but you got to start fighting about it in the 4th grade.
Actually, along those lines, a number of the Women in Aviation, which is another organization, they do a great Girls in Aviation Day every year, and do it all at the local airports. And that's the age group, because as you said, all the research actually does point to that's where they lose them. And so they do and we do these are across the country. It's a Girls in Aviation Day, and it's geared toward that age range.
Good for you. That sounds great.
If I may add one more advice from my wife on that, sometimes it's as simple as telling them you can do it. They don't hear it from home.
Yeah.
Many of these people do not hear that one encouragement from home, and she has to tell them, and they say, really, I can do it? It's as simple as that. A lot of those people just need to be told that they can do it, and they will do it. My wife says that you tell them to the students, and the students suddenly come back with projects and teams, and write her letters a few years later how successful they became out of this one encouragement that they never heard from home. I think this is key. The other thing that I wanted to mention here is that I'd like to second and emphasize the concept of failing forward. I think it was from the lady from UC earlier, which is, I think, really a very nice concept. You can Google it and get tips on how to fail forward. I mean, you fail in life, that's the reality, but how to fail forward and not backward. I think it's something that everyone should adopt, not just when you're sick, your next job, but in life, how to fail forward.
Advice I usually give at the end of this thing is believe in yourself, know how you think and how you process stuff, but dance like there's nobody watching, because don't lose faith in yourself because you hear a negative word.
Absolutely.
Exactly. And always say no to naysayers.
Yeah, right.
So Sina, Phil, Joy, do you have anything you would like to share or comment on this? Give some suggestion.
Well, on the female subject, I actually had a lot of really hardworking and intellectual female students. I'm gonna say, statistically speaking, I probably had like around usually between 5 to 10% female students, and they were all pretty smart. Even though they were not really engaged, I think they're they're kind of like maybe they're kind of like socially embarrassed, to like get engaged in even class discussions. Like I usually had like male students asking questions in the class, and I had to answer. But most of my female students, they got really straight A, so no complaint. Like they're very intellectual, highly intellectual.
Glad to hear it.
Again, I don't have too much more to add. You know, I think everyone's right that the composition of graduating classes, composition of winners of certain prestigious awards has been changing in the right direction. It's not quite 50-50 yet, but it's in the right direction. I know I can speak for our shop and the positive cultural change that has happened as we've hired more women. What's key is hiring more women, not in the front office, but hiring more women on the manufacturing floor has been a critical change to our culture on the floor. So we have 80 employees. I believe we have about 7 or 8 women, which is not very many at all. But now, you know, consider the environment and the cultural history of the environment we're in. So we've seen that growth in number of women on the floor just in the last year and a half. It has changed the dynamic on the floor and the productivity on the floor dramatically. We have found that the females on our workforce, either in engineering or on the floor, are significantly better at learning new concepts and repeating that concept over and over again, which is critical in a production environment such as ours. So there's no stopping what can happen here as long as the societal constraints are taken off. The natural abilities speak for themselves, and I've seen it firsthand in our company, even in a stodgy, you know, greasy machine shop such as us.
Okay, so Bill, Mr. Barnes, if you have anything to comment on this woman minority, or if not, there's something in general you'd like to give advice to the attendee students.
Right here beside my computer is my favorite mathematics textbook, Mathematical Methods in the Physical Sciences, written by Mary L. Boas.
Yeah,
that's all I have to say.
Yeah, no, yeah, I understand. Very good, very good. That's everything. Very good. So before we move to the breakout session, if any question from the audience, please raise, but you can also ask individually when you go out to the breakout session. So just before finally, if any of you, the panelists, want to say something, add more quickly, please go ahead. Otherwise, we'll start to assign the breakout room.
Yeah, can we take a 5-minute break?
Oh, you want to take? Yeah, but sure. But actually, the breakout room is kind of break, you know. So my personal feeling is, you know, we can keep moving, and if you want to take a break, you take a break.
Okay.
Yeah, because the breakout is kind of networking, so it's casual, you know. Okay, so.
Are you assigning to the breakout rooms, or do people go where they want to go?
So what we'll do is each of you will put in the separate rooms, and the attendee, they are welcome to go wherever they like to go.
Great. Okay.
Yeah. Okay, so we'll start doing that. So for example, for you, Dr. Leo, that would be in your room. So we're going to assign you first. So Dr. Here. So, and for Jennifer, you are going to you are the leader of your room, and Phil, you go to this room. The student attendee might take turns, so you will see what's going on.
I don't know how I get to my breakout room. How do I do that?
I'm assigning now. So I'm assigning, then we'll start open the room. So just a second. So
okay.
Now is Dr. Melamed. Okay, that's you. And Bill, now is your turn. Jyot and Mr. Bawa, and that's it. So we are open. That's it.
Okay, bye everyone.
Bye.
Bye.
Well, you're welcome to come back, you know, anytime. So anyone, you're welcome to join the, you know, the session. Like for example, Diana, you can choose which one you to go, or you can tell me which one room you want to go. say, Diana, do you want to go which one first? I can assign you, or you can choose yourself.
Yeah. Okay, we can choose them and then like hop in to ask.
Yeah.
Okay,
Please
cool.
go.
Got it.
Benefit,
Okay.
fully
you.
engage with them. So can
Thanks,
you
Diana.
select? Or you
Yeah,
want me
yeah,
to...
I can see. I'll
Okay.
select it. Thank you.
Very good. Go ahead. Ian, how do you think? Ian.
Hi. Where do I go to select my breakout room?
Can you see the breakout room?
Like a tab for breakout room?
Yes.
I'm not seeing it on my end.
You're not seeing it? Okay. Okay. You're using cell phone or something?
My laptop.
That's it. Okay. So you can let me know. So for example, which one you want to talk first. Then you can come back, and then you can text me. Chat and text me which one you want to go next. So for example, which one you want to go? You want to go with, say, Phil or Sina or anyone?
Let's see. Can we do Bill?
Okay, let me assign you to Bill. Let me see Bill. Sign. Yeah, so you're welcome to text me and then chat in the chat room, say you want to change to somebody else, anytime. And you can always come back to the main room. Okay, you're going to Bill.
Okay.
Okay, so on Prakash, Mr. Prakash, can you see the signing room? Vitali? Bob, do you want to talk to somebody? Oh, Alex.